Hi guys, and welcome back to the series. Since in the last episode I didn't really get a chance to properly explain the error, I'm going to do so now. We're going to make some changes. Instead of doing a time-lapse accompanied by Toho music, I'm instead going to do all the programming live from now on. And I'm going to explain things as I go along. Now, you might think that this would take very long, but what I'm going to do is just press the pause button while I'll type the code out, and then I'll explain things to you. Let's try it right now. Yeah, something like this. What we want to do is maybe do some what I've just done is a bit of factoring out, and I've separated out the expression that was in the backend switch. This part here works very well, and we could very easily do the backend switch macro if we could do this part inside as well. But the main problem is that we don't actually have the language feature needed to do so. This gray symbol takes in a type, so it could be something like an int or anything else basically. And this works pretty well, but it doesn't support the stuff between the parentheses. So as a consequence, we are much more limited than we could be. We can pass in single variables, but we cannot pass in and apply functions inside the macros, and that is a very big disadvantage. And unfortunately, it is one that we're going to have to fix, and it is going to take some time. Let's put everything back. Right now, this cannot be parsed. So for the time being, we'll leave it like this, so we don't have type errors everywhere in the project. Let me just check. Do we have any type errors? Okay, let me fix this real quick. Oh, there, now the type errors have gone away. We'll make a checkpoint here. And that takes care of that. Our goal is to enable the parsing of this particular fragment, so we can implement the backend switch for types. In case you aren't familiar, or maybe haven't watched the earlier videos, we have a backend switch on the term level. And what it does is allow us to make a backend specific code. For example, we've used that in a bunch of places. Oh, like over here. This particular assert is polymorphic in terms of the code it can produce for different backends. This is how it's done on the Python side using a macro, and this is how it's done on the CUDA side. And in fact, over here you see one of the issues with not being able to apply the types inside the expressions like this. Right now we can only use a type case to bind the type to a variable before passing it into a macro. And it would be a lot better if we could do something like yeah, something like this. But as you can see, right now we're just getting type errors. And yeah, I don't really like having to use type case myself here. But you know, it's the reason why I did that is because it's easier to use a type case than redesign the way macros are being parsed. But in terms of the types, I mean, in terms of the type definitions, it isn't really possible to make an intermediate binding. So that is why we have to do it like this. In fact, let me just think about it for a minute. Okay, you could in fact do it exactly like this and it would work, and we wouldn't need to redesign the tokenizer. I cannot believe that I didn't think of this earlier. Well, I'm not sure what to say right now. I was pretty determined to redesign the tokenizer, and we're probably going to have to do that because that's what I intended for this video. And okay, what the hell, we can do it without the tokenizer redesign, but let's do it anyway. Because right now, even if you unpack this, you just get something like a real nominal. What I intended for this video today is to make a language tutorial on how to do tokenization. Oh, not this thing here. Okay, this we can just erase. I just prototyping that in the previous video, but it's pretty useless. And what we have to do is basically rewrite this whole thing, but it probably won't end at just that. We'll have to rewrite pretty much everything here in the new style. I mean, it isn't really as much as it seems, because the tokenizer compared to the parser itself, which works on the tokens produced by the tokenizer, is a lot less complex. The macro itself that you see here is probably the most complicated piece of code here. And what exactly is the problem? The problem is that this code is, well, it's shit. A few months ago, I was speaking on a bunch of CUDA codes that some CUDA developers worked on for the matrix multiply. And now, in the interest of fairness, I'm going to have to pick on my own code and say the same thing. While I was writing this made sense. I was really cached into the code, and that allowed me to reason in ways that I couldn't really do ordinarily. But what do we need in order to actually extend this? That is the real problem. It's not that this code is bad in isolation. Okay, here's the... it's combined with the spaces. And now where is that big list that has all the... where is the macro? Oh, here's the macro. This is... this particular function combines all the tokenizers, all the individual tokenizers into a single one. And the macro is here. But the problem is that if you want to parse things between parentheses inside a macro, that would end up conflicting with the other tokenizers. And I think, yeah, I have this brackets tokenizer here, and this one is dedicated to just parsing the brackets, and it creates a tokenizer like this. It has tokenizers for all of the 6 cases, for the round parentheses, for the square parentheses, and for the curly parentheses. Oop. And suppose what I would do, what I would need to do inside the macro is actually is to actually pass this outer token here. Something like, we need to make this recursive. And then we need to pass in this recursive function into the macro itself, so you can actually call it in order to parse not just the quoted strings inside the macro, but everything else inside it into other tokens. You can see, for example, how that would work in how interpolated strings work in Python or even F#. For example, in F# you can do something like string I'll pause. And as you can see here, this is how interpolated string looks like in F#. It's pretty similar to how it works in other languages. The one thing I've noticed that in F# though, it doesn't actually allow having strings inside of interpolated strings. This for example gives me a type error, and it's kind of annoying. Single quote or repeating string literals might not be used in interpolated expressions in single quote or verbatim strings. Basically, it's telling me to do what I just did here. And this is a minor gripe with how interpolated strings work in F#. It's not really a big deal. And I want to allow something similar to that in macros, because right now macros only allow single variables. You do something like bank if you want a term variable, grave if you want a type variable, and at if you want a type literal. And what we want to do is allow the parentheses. So the idea is basically, the first idea that you come to is to extend the already inbuilt macro in order to not really have to do a lot of work. So let us find where the macro is again. Okay, I'll pause. And here it is. And in order to actually extend it, what we need to do is maybe add an extra argument here and here and here. But after that we have a problem, because as you can see here, this is a parser for the variables, and there is all this stuff here. It's pretty complicated, and when you look at all of this, how would you basically extend this? Where would you even use this token argument? Because I'm not sure myself, and I wrote this entire thing. So what exactly do we do? There isn't really much that we can do. What we need to do is rewrite the macro Tokenizer in a high-level manner. We'll have to rebuild it from scratch, and the best way to do that is to actually first prototype it using something like Fparsec. And we've used that in the past to do a similar thing in one of the previous videos. We actually, it was in the F# playlist, and I'll quickly find it. It's this video here. It was while I was working on the VN compiler called Helix. Eventually I got really bored of that project. It was taking too long to get anywhere. And let's go forward. Okay, let me pause here again. Yeah, take a look at this middle node here, right above the cursor. This B is supposed to be a bolded section of the text. And for that, and just for that, we have to do a parser. And it's not really as easy as it seems, because these nested these B's could also have other tags inside of them. So to actually parse this properly, we need to be able to parse closing tags, closing parentheses, in such a way that it ends up being correct, of course. But imagine we had a parser to just parse a bunch of text. Then, if we let it parse, for example, the hello world, it would also parse the closing parentheses when it shouldn't. We need to actually structure the parser so that it parses the outermost expression and that the inner expressions are properly nested. And for that, let's go forward a bit. I thought it was kind of how the parser worked was a bit interesting. Let me pause a bit again so I can study it. Here's the code for it. In order to actually make it easy to model, we created this recursive union type. This A here is the first field. This string list are the CSS tags on the left side of the curly brace. And those are the bold, italic, and so on, the CSS tags. And this here inside of it is supposed to be the text. And as you can see, they are mutually recursive. The text is actually this thing at the bottom, and it's a list of this string here, which I'm not exactly sure what it's supposed to be. Yeah, it's supposed to be the text, and this A option are the nested tags, and we did it like so. So arguably, instead of maybe, yeah, I mean this is fine. It would also have been possible to, for example, also define a union type, which is either a string or an A option, and then make this B type here a list of that. And over here we have the individual parsers. This one is for the CSS tags, or maybe not. It's looking for a string made of letters, underscore, dash, digits. This is the parser for the type A. You can see that this is exactly the reply type, so you can be sure that it produces the A type. And it starts off by parsing the percentage character, then it parses the CSS class, and then in between that it reads and then it uses the between parser combinator and reads the opening brace and the closing brace. And actually, I meant to say that it reads the stuff it parses the B type in between the parentheses. That's what this parser does. It's an Fparsec parser. And this stuff that's going inside the PB parser, those are the blockers. What the blockers are is, as I said, we have this. Excuse me, let me locate it again. Oh yeah, we have this string, for example, here, and we have many nested braces. And without a blocker, for example, this parser will start parsing the digit 9, and then it would parse the closing brace. Instead, we want the nested parser to actually stop at the closing brace, and then let the outer parser actually parse the closing brace, so it can actually parse the whole expression properly. I hope that makes sense. And without these blockers, the whole thing wouldn't work. And that's the main thing that's very difficult to do in the Tokenizer right now. We're going to have to enable that somehow. And we'll maybe use this parser as a model for what we're going to do. So, okay, let me think what we want to do. Let's start a new project. Okay, I'll pause here. Just now I opened a new project in Visual Studio, and yeah, we're going to start things off here. What we're going to do is install the Fparsec package. Visual Studio, I mean, if you are on Windows, it's pretty easy to use. We'll do, we want to install this one, not the big data or the pipes, just this thing. And after that, we can start writing a parser. Before we start, we also need to take stock of the Fparsec documentation. It actually has a pretty good documentation. It's a descendant from the Haskell libraries of a similar name, which was called Parsec. But when I actually looked at this library, it had worse documentation than Parsec. So take that as you will. As it seems that the last release was like 4 years ago, but that doesn't matter, because that just means that the library is perfect as it is. And it's a very good library. What we want here, I mean, if you are familiar with it, I definitely suggest that you go through the tutorial. Here it's showing how to parse a single float, how to parse a float between brackets. It also has, I mean, this is, I'm surprised that it's actually showing this example when Parsec has a between parser. Okay, let me demonstrate that for you. Oh yeah, something like this. And now if we run this, actually accidentally entered into the debug mode, sorry about that. Let's try it again. Yeah, now we get expecting opening parentheses. So this parser is actually giving us the correct error in this case. And if we do something like if instead of passing it the hello string, we instead pass in an actual number 1, 2, 3, 4 like this, then we run it with Control F5. What we get is the success 2, 3, 4. And that's basically how it works. Suppose you had some white space like this, you'd get an error. It's saying that it's expecting an opening parenthesis, and then you can use parser combinators to combine the parse float with something else. For example, one day I'm going to learn how to properly select the layers on my keyboard, but for now we will just have to make do. If we run this, it should parse this string correctly, right? And as you can see, we have the spaces parser here, and it says that it skips over any sequence of 0 or more white spaces, space, tab, or new line. And then when we compose that with the parse float, it manages to parse this string. Now suppose we put in some, for example, some stuff at the end of the string like this, and we run it. Yeah, we still get a success, but maybe we want it so that it only parses a single float. In that case, we need to use the end of file parser. Expecting end of input. And the error messages are quite good. It gives us the exact location where the error is happening. And actually this is one of the reasons I probably decided myself to do my own parsers instead of relying on Fparsec. But never mind that. Anyway, what we need to do is make a parser to pass arbitrary strings between parentheses. So let's start with that. What we actually need to parse is the full things, which looks something like, okay, let's put in a white space or two at the very start of the string just for show. And yeah, now we need to unescape them because this is an F# string. Okay, let's maybe do things a bit Okay, let's make a text case like this. And we'll make one of those spiral macros here, right in the middle. And then we have the backend switch. Then we have the grave. And then we have a parentheses. And then we have something like CUDA. Okay, let me pause while I type it all out. We'll just copy it, paste it from here. I mean, why am I typing it out? I have no idea. Yeah, great. This is the kind of expression that we need to parse. And so, for starters, let's make it our goal to parse just this part. So we need the spaces, and we need, for example, something like parse macro. And this one needs to be the end of file, something like that. Okay, let's make it end of file. And we'll also maybe put in some spaces, like between the end of file. I mean, it doesn't have to be the end of file directly. It could be something like a bunch of empty spaces and a new line. But it can be like this, for example, but not like this. There shouldn't be any more letters or digits in between it, or symbols. And now this is giving us a type error for some reason. Oh yeah, it's parse float. Yeah, and I mean, actually I wrote it out. And we don't need to parse floats here. What we do need is to parse the macro itself. So let's get started on that. I'll write out how it should be initially, and then we'll test it piece by piece. And here is the start of our macro parser. Let's give it a try. If we run it, we actually do get an error at the very start of the code. And this is, how it should be. It's expecting the end of input, but it got something else, in this case a quote. And we know how to parse a quote. We just need to use the between parser. So let's do that next. Something like this. The first two arguments to the between parser are pretty straightforward. We just need to pass in the quote parsers. But as for the third argument, that's a little bit more complex. For the time being, rather than trying to parse this whole thing, how about we try to just parse everything in between as regular text? And now we certainly won't try to tokenize everything. Excuse me. So how could we do that? What we need is basically a parser that takes characters until it hits a certain string or a character. And there are such parser combinator functions in the Fparsec library. Something like maybe... Okay, let me pause here and I'll find something. Let's go with this one here. It's called many satisfy. If you read the documentation, we see that many satisfy f parses a sequence of 0 or more characters that satisfy the predicate function f. Yeah, characters for which f returns true. It returns the parsed characters as a string. It says that it converts the carried return characters to new lines, and and the rest is basically something like that. Now let me think. Okay, let's give it a try. Of course, there are other parser combinator functions that we could use apart from many satisfy, and many satisfy is just the simplest one such function. The more complex ones, instead of passing a character into the predicate function, actually take other parsers or even strings, strings or even other parsers as arguments, and they parse until the predicate parser actually returns a success or something like that. So let's do something like this. Something like this would be a good first attempt. This will parse characters as long as they are not a quote. And if we run this, what we get is apparently nothing. I'm not exactly sure why this is acting like this. Shouldn't this return a string? Okay, let me pause here and I'll debug this for a while. Let me just note first that I was expecting it to return all the stuff in between here and the first quote, so something like this. And instead we're getting an empty string. So let's figure out why that is happening. Yeah, also another thing, it's actually returning a success. And because we have this E of F here, that means that it's in fact parsing everything up to the end of a file. So that means it's actually parsing pretty much everything. And it's returning nothing. And we'll figure out why that is the case. And I figured out what the problem is. It's actually pretty stupid. I forgot to pass in the test case into here. Sorry about that. Oh, whoops. Okay, now we can run this properly. Let's give it a try. The error occurred at the end of input stream. It's expecting a closing quote. But instead, over here it's passing pretty much everything. So if we put in the condition back to the way it was, what will we get? Let's try running this. Yeah, now we're getting the error that I expected. It's parsing everything up to this first quote, and then it errors out, saying that it's expecting the end of input. So what I need to do is somehow nest these things, these nested macros. Let us first think. This macro is not inside another macro, in fact, but it's in the type variable or a type expression, which it will be from here on out. We need a parser to parse these type expressions first. So let's do that. And in fact, to make things easier, let's define a few union types, like we have in the VN compiler. For example, let's make it T. We'll name it to something better later. I mean, there's nothing wrong with starting off with short names like this and then renaming them later. Like in Visual Studio, you can just press Ctrl RR, and it will rename all the occurrences of the type. It's no problem at all. So we need a text token of string. For now, let's also make a type expression. Of the list. Later we'll add also term and type literal expressions, but for now that really doesn't matter. In fact, we could just add some kind of type here, like type x could be like type or term or type literal. Who cares? Then it will be like this. Now, what do we do with this? Well, as long as it's just something like plain text, we have to parse like two different things. We have to parse the regular characters up to a closing quote, or until the grave character, or up until the bang or the et characters for the terms and type literals respectively. So let's do that. We have this parser here, and I guess we need to also extend it, something like or c not equals grave, or c not equals bang, or c not equals et. Now what we should do is parse everything up to this opening parenthesis here, I think. Let's give it a try. Error occurred at the end of input stream. It's expecting. Oh wait, no, that isn't right. It should really be stopping at this first character. So why isn't that happening? Okay, let me pause here so I can research it out. I figured out the error. Instead of the or operators, we should have been using and. Now we'll get the proper error, and indeed we have. Great. So let's make this maybe. Okay, this is the macro parser, and we need to also make a text parser. So let's make it something like let text. And the naming is a bit long-winded, but whatever, it's fine. And we'll copy this thing, let's say, we'll copy it here. Now we can just factor this parser out and put it back in here. But instead of just returning a string like this, what we can do is actually return a text expression. So something like this will wrap the text in a union type. And parsing a macro will be a combination or a list of text and other expressions. Let's make a parser for the expressions. Parse exp. And okay, for now let's just focus on parsing the stuff between the parentheses. I'll pause here so I can implement it. Yeah, this is a good way to start things off, but of course the expression parser shouldn't be parsing text. Instead, what it should be parsing is a macro. Of course, the macro is below the expression parser, so we cannot really access it. In order to actually do that, we need to make everything recursive. So something like great, now everything is recursive, and we can in fact in a mutually recursive block like this grab the variables that are defined below the one that's current. And this is a great thing to know. Of course, we're getting this warning. This and other recursive references to the objects being defined will be checked for initialization, soundness, and runtime through the use of delayed reference. The reason why we're getting this error is because the stuff it's trying to access might be undefined or null. So it has to do a bunch of checks to make sure that this doesn't actually trigger a runtime warning. Because over here we don't have functions, but mutually recursive objects. In Spiral, unlike in F#, we only allow mutually recursive functions for that reason. So, okay, let's ignore the error for now. We can parse the macro. The macro is basically parsing the text. And let's make this type macro. And okay, let's see what happens when we do this. We should probably get the same error. Where is T? Why is T not defined? Oh yeah. Macro list and expression. Yeah, now it's now we're getting the same error because it's just it starts parsing the macro, then it reads up to this, and then it doesn't know what to do. So what we need to do is, instead of parsing a single text, it needs to be some kind of combination of text or an expression. Let's do that. Parse text or parse expression, not parse error. Parse why is this happening? What did I do? I accidentally turned on this. Okay, let's do this. For fuck's sake. expr. Okay, great. I guess the IntelliSense was a bit wonky right now, and we're getting some kind of error. This value will eventually be evaluated as part of its own definition. You might need to make the value lazy or a function. Yeah, we need to turn these into functions, as could be expected, and that's actually very easy to do. We just need to add an extra argument. Okay, let me pause. Yeah, you can just turn a mutually recursive block of objects into a function by adding an extra argument. And in our case, this reply type, if I hover over the parser itself, you'll see that actually not the reply type. The parser itself is a combination of this stream object and the reply. It's actually a function. All of these parsers are functions. It's a car stream arrow reply. So in order to turn it into a function, we can just make the argument explicit instead of relying on partial application. And great, now we should be able to compile this, though it still won't be correct. And the reason why it's still not working is because it just parses the text, but then it errors out after that and doesn't even try the parse expression. So what we'll do is combine these two. Instead of expecting just a single text, we need a list of texts. Let's try it like that. Many of these expressions. And what? expecting a reply macro, but given a reply macro list. Oh yeah. We also need to take care of the stuff here. We need to actually turn this into a proper expression, and we can just feed the value into this is the initial value, and this expr will in this case just be type. And now we're still getting type errors for some reason, and I'm not sure why exactly. Okay, let me just do this. Okay, let me pause here so I can figure it out. I figured it out. Basically, we were just missing a closing brace here. For some reason, when I opened, when I wrapped the parse macro in a parenthesis, it removed one at on the right side. I have no idea why that happened, but everything is fine now. And now if we try running this, let's see how far we get. Combinator many was applied to a parser that succeeds without consuming input and without changing the parser state in any other way. Oh yeah, the great thing about Fparsec is that it does checking for whether a parser diverges. In other words, whether it succeeds on parsing an empty input. If it does, then it raises an error. So what we need to do, instead of many satisfy, it needs to be many satisfy, actually many one satisfy. That will instruct the parser to parse at least a single character inside a macro. So arguably this isn't really a perfect solution, because it still expects to maybe parse, it should still be able to parse an empty macro. So instead of requesting that this parse a single character, maybe this should parse at least one. So I get the sense that this won't work. No, it won't. So maybe what we need to do, okay, let's do it like this. Many ones satisfy, and this should at least get around the recursion check. Okay, we're still getting the same error when I was expecting it to pass the stuff between the grave. But what I meant to say is that later we should also implement a case for an empty macro and just return that if, for example, this part here, this part here, if it fails without changing the parser state, something like this. Yeah, empty list. Yeah, this is like a special OR operator, parser operator, where on the right side you can just put in a constant and it will be roughly equivalent to writing something like this. For example, if this what this means is that if this many operator, parser combinator fails without changing the parser state, then it will return the stuff on the right side. Now let's see. That shouldn't make any difference in this scenario. Now, why isn't it parsing, this opening brace? I'm guessing it could be because parse expression, it will skip the character. Okay, let me pause. I figured it out. Basically, these should be closing and opening parentheses. I have no idea how I missed this. I thought that I changed them, but I guess I didn't. Now let's try running this. Now what's the problem? expecting a dollar or a closing parenthesis. Okay. Let's make it like this: parse macro inner. This will just parse the inner part of a macro instead of the outer. Something like this. We'll pass it the yes argument, and the parse macro inner. That should be here, and it should be here as well. It's easy to factor things out in F#. And what in particular makes it easy is global type inference. Now it seems like we forgot to there should be an opening parenthesis here, and it's complaining about the empty list here. And yeah, it's returning an empty list here. Maybe what we need is something like actually probably not, but no, it needs to be a macro, so it's a macro list. That much should be clear. So what exactly is the... Yeah, it should be returning a list, and this should be passing it into an expression. Okay, I'm going to pause it here again so I can figure out what exactly is the problem. Be right back. Yeah, it was another parser error where we forgot to put in a closing parenthesis. Now, some of these other errors have gone away, but we're still getting a type error here. It says that it's expecting a macro, but we give it a list. Oh, okay. So we've put the parentheses in the wrong place. Okay, let's do this like so. And then let's do this like so. Oh yeah, great. It's actually quite difficult to figure out what the type error is just by reading it. You have to reason a bit more broadly in order to actually understand it. And that pretty much goes for all the functional languages. Because they are more expressive, it's harder to have them give out good error messages. The type errors generally are type errors. It's just they aren't really placed in places where they'd be the most helpful. And by getting good at functional programming, you'll be able to get better at programming in general. So it's well worth the investment, assuming you want to become a programmer. Oh no, let's see. Okay, we're parsing the inner part of the macro, that is the stuff between the quotes. So now what exactly do we have to do? It's parsing the expression here, it's parsing the text. Okay, so far so good. Let's try running this. Yeah, it cannot parse the inner macro inside the expression like this. So let us think about this for a bit. The inner macro let me pause so I can think about this problem. For example, do we even want to allow the inner macros? Obviously, being able to use type level functions inside the macros is very important, but macros inside macros aren't, because they can easily be substituted by type level functions. In particular, the troublesome part to parse is this $sign here. If we allow the parsing of this in the regular tokenizer, we'll have a problem because it won't be able to parse the regular dollar strings, I think. Okay, we'll think about it for a moment. Okay, I decided how I want this to be done. Basically, we're not going to do the expression like this. Instead, the expression should just be a string. Easy peasy. And the macro itself will get, the macro parser or the tokenizer itself will get called in a nested manner on this expression by all the other tokenizers. By the other tokenizers, I specifically mean pretty much everything else in the Spiral language repo. Pretty much all these things here. And the macro parser is just a part of that. So for now we can just leave it as a string. What we want to do here is just factor out all the parts of a macro so it could be more easily tokenized later. This is actually different than what I originally envisioned. Originally I envisioned that I have to rebuild pretty much everything inside here, but that's not necessarily the case. Instead, I'll make the macro tokenizer I'll actually just tokenize it in multiple stages, and that will make everything much easier. Let's get back on track. So this parse text, it doesn't really have to stop on a quote. It just needs to stop on a closing parenthesis, I think. Alright, initially it does need to stop on these. Okay, let's do it like this. This should be a set of characters. In F# you can you can put in the arguments in the opposite order, and in fact that's the only thing you can do. While in Spiral you write it something like set car if it had a set type. But the disadvantage of this is that you cannot really put in multiple arguments to a set. Instead, if you had something like a map car, oops, sorry, I meant to put that inside. You need to do it like this. So I like the Spiral version better, but it's elegant for something that for types that only take in a single argument. And we can just do something like a set contains C blockers. Now that we have this, we need to keep passing the blockers around. We have a parse macro inner. Okay, let's do blocker. Actually, we don't need to do it for this. We just need to parse a closing brace, and that's just a singleton set. Now, if it parses the text, it will parse all the way up to the end of this. And also parsing the expressions becomes much easier. I don't even think we need this recursive formulation anymore. Okay, maybe we do need it to be empty. We do need it to be a list of macros. But I don't think we need it to be recursive. We'll see. Okay, it's parse text, parse expr. And yeah, we can just do between okay, yeah, we can just do many one satisfy. We don't even need a blocker. Many ones satisfy c not equals closing parentheses. Okay, great. And we can even make it a bit more succinct by just writing it like this. Okay. Now it's parsing a string. It's parsing everything between. It's parsing the text. Many. Okay, and we need to pass it the blockers here. I think for just parsing the text, yeah, I should be parsing everything. Set in fact, we could just instead of passing in a set of blockers, we can just pass in the predicate function. And what was that again? Not equals. We're going to have to write it all out. Let me pause. Okay, we have this predicate function here. We just pass it into this. I mean, right now I'm wondering why do we even need this? If we're just going to be passing in the predicate function. Whatever, let's do it like this. Parse text. Yeah, now it's parsing the inner stuff. And okay, this isn't too bad. Yeah, we can just leave it right there where it was. Let's do it like this. It will either parse the text or parse the expression. And this expression here can just be left for the latter stage. Okay, let's think. No. Yeah, I mean, it all type checks, so it will probably run as well. Let's give it a try. Success. Text, backend switch, expression, CUDA array, Python list. It's a type. And there is a closing quote for the text at the end. Why is that there? Why is that? I mean, yeah, as you can see, there is somehow accidentally left a closing quote. It should also account for the empty spaces, and it does. If, for example, we get rid of that empty thing, it should get rid of the text at the end instead of leaving in an empty text. Yeah, great. Okay, this is perfect. Let's also test the empty case. Great. Also, yeah, what we also need is the other blockers, and for the expression we actually need like 4 of them. Let's see, let's skip any any character. Skip, no, not any character, skip any of. And yeah, we'll pass in all the characters that can be skipped. That would be the grave. It would also be the bang. And it could also be the yet. Yeah, not bad, not bad. Oh yeah, but we also need to account for the type of the expression. So let me think, how could we do that? And unfortunately, okay, let's do any of. Oh yeah, there's not just a skip version, but the any of, and it actually returns the character that has been skipped over. So if you do it like this, now the x will be yeah, no, not this x. Instead, we'll move this to a different place. And we'll move it to the outermost level. And we're not getting a type error, so there aren't enough parentheses. Let's do it like this. Yeah, now the x, if we hover over it, it will be a tuple, or more precisely a pair, which is just a pair is a tuple with two items. It's a character and a string. This first character is the character that has been skipped over, and the string is the stuff between the parentheses. So let's do a little function. This will be, we'll do a little mapping to this will be the type, and we'll duplicate it a few times. Term type literal, and you can probably guess what will come here. And this will be an exception. Compiler not expecting unknown char. Yeah, something like this. And we need to name this function better. So we'll name it char2 macro expression. Macro. I will name it this to the. We'll rename it into macro expression. And now we'll select all of this and then just put it here. I mean, use it here. Okay, let's see, t and x. What the hell? Yeah, great. Now we should be able to parse pretty much anything. Let's do bang. Hello. One, two, three, four. And if we try to run this, text back and switch expression is of type, and this expression is term, and this expression is type literal, and it's all in a list. Okay, no, not bad. Now we are very good at parsing stuff between the parentheses, but we also need to parse the stuff not between the parentheses, but in variables. So we also need the parser for the variables. And the question is, how will we do that? Well, let's take a look at the tokenizer here. How are we parsing the variables here? We have many satisfying one. L is variable character starting, and this is variable character. Okay, let's do it like that. Does everything need to be recursive? I don't think it does. So we can just let this be a regular let. Yeah, no problem. I'll let parse var. But it could also be in the case of type literals, it could do. Yeah, actually, this is interesting. I don't think we can, in fact, tokenize the type literals like here. Let's give it a try. I mean, in Spiral nominal. Yeah, I actually forgot this little detail, but we don't. But it's expecting a variable here, and we cannot actually pass in a straight up literal into the type literal operator inside macros. Okay, so we don't have to worry about that case. I mean, these operators inside macros were made to pass in variables, so it doesn't really matter that we cannot pass in literals. It's not really a design flaw by any means. Now let's take a look at where this is defined. It's var starting. It's just checking whether it's a letter. So okay, let's copy this into the other repo. I guess we need to open the system namespace, and we also need this other one. We'll take a look. And this one is also allows for digits. Right here it's checking whether it's a letter or a digit, and it also allows for the single quotes inside the variable names. Actually, we need to copy everything. Now let's copy it into the macro tokenizer. And it's complaining about something called what is it? The value restriction. The value restriction is when it needs to fill a meta variable in the parser, but it doesn't know what it is. So the easiest way to get around it is to just make this a function. Yeah, okay, good. Okay, now we can parse variables. So what we'll do here, instead of just parsing the stuff in between the expressions, we'll also allow parsing of variables. So okay, let's see. How will we do this? At this point we need to start breaking the expression up a bit. And we'll do. Okay, let's start. Let's make this like so. Let case paren. And this will be the case for the variable parse var. Okay. And now what I will do here, yeah, we also need to do something along these lines. I'll pause for a bit. And here it is. This is what we need to also parse variables. And you know, whenever the one-liner starts getting too large, you have to begin factoring things out. It becomes more readable like this. Now, what will happen if we try running this? Let's see. I mean, it should still work, but now it will also be able to parse the stuff between the parentheses. Right? If we try this, it won't work like in regular spiral. It's expecting a variable or opening parentheses, but if we give it a variable, yeah, now the expression is this variable, which is perfect. And yeah, I think we could probably find a way to actually fit all of this into the original Tokenizer without necessarily tearing everything up. So the one concern is, even though the Tokenizer looks like very similar to the Fparsec one, it's not actually using Fparsec, but something that I made manually. You can see everything here, and we have skip character, skip string, spaces, character still string, but we don't have everything that Fparsec does, so we'll have to implement it as we go along. And this will simplify this macro parser significantly, because instead of having to parse the nested macro invocations like this, we'll be able to just do it in several stages, and that will be a lot more palatable. So let's see. Okay, we don't need this token anymore. I mean, this isn't. Do I really have this one? Oh yeah, I implemented this. It's pretty similar to the Fparsec version. And I really don't know why I didn't just use Fparsec. I remember wanting to use it originally, but for not very good reasons, I decided to roll everything on my own. I guess I thought it would make something like maybe error handling easier. We'll see. Okay, let's just first try to somehow paste it here and reassure ourselves that there aren't any errors. I'll pause here for a bit. You can see how it looks when it's pasted inside of here. We are missing some key parsers, but they'd be easy to implement. In particular, okay, we don't need this one. We just need the macro parser and the pcar parser and the between parser, these three. So let's implement them in line parsers. The any of parser. Okay, let's start with that one. we'll start it off with an L to signify a list. Then we're getting the tokenizer here, and then we have to actually implement the functionality. So let me think. What do we need to do here? We first need to check whether the current character is inside of one of these. So something like if list for all, or maybe list contains. I don't think that the list contains. Oh, this does actually exist. Not bad. But it doesn't really give me the character that's actually inside the list, and we need that as well. So, okay, let's do it. Let's get the correct character, and that would be pick S. That just picks the current character. Then, if the list contains the character, oh yeah, then that way, then we'll know which character is the current one. It's just this, the one that we picked into. Okay, list contains, and it's not list contains, but in this case it's sequence contains CL. If it contains it, then great. Then we'll that's the success case. We'll probably need to return the current character and move the tokenizer one step forward. Let me think about how that could be done. Okay, this is how I imagine the any of parser combinator should be implemented. This part I hope is clear, but this part is just returning a list of errors with for each of the specific characters. And now the any of is done. Next we need the between, and the between can be implemented using other combinators. Let's see. Oh, okay. For now, let's just do it like this. A, B, C, A. Actually, it needs to be something like C, and yeah, now we have the between parser. Let's see, could we maybe do it a bit better? Oh, just where are the operators? Oh, it's in parser combinators, so I don't think this will actually work here. Line parsers, parser combinators. No, it wouldn't. These parser combinators were intended for the parsers that work on tokens in the block parsing module. So all the way here. And this is where they'd be used. Yeah, compared to Fparsec only works on strings, so that's why I had to create my own parser combinator library just for tokens. But it's not really that complicated. Everything looks pretty much like this. It's straightforward. Okay, now let me think. So we cannot do it like this. Instead, we'll have to do it. Okay, let's try something like. Maybe it would work on the tokenizer. I don't know. I'm pretty sure that it won't work, but oh, it does work. No, it's taking is in this A thing. That isn't good. Oh yeah, but that's just because we haven't passed the tokenizer into these. Result and the errors. this really work? Let's take a look. Actually, it's in Tokenizer, not in line parsers. Yeah, between. And we're still lacking the pchar parse character. Okay, let's define that one as well. And that's. I have the skip char, but not the pchar. So we could use actually that one instead. Whatever. Let's just make use of that. Yeah, we should be skipping the characters here, not parsing them. And this should be. We're just adding an optional an argument to actually close that we are looking for the closing parentheses. No, wait. This will be a proper error, not the closing parentheses. This is basically. Okay, let's do it like this, not closing parentheses. And yeah, now the between actually works. Tokenizer result, string range, string list. And it's telling us that there is a type mismatch. Expecting a tokenizer result range character. But it's returning a range result list. Okay, let me pause a bit so I can think about it. I figured out what the problem is. This should be a list and not a generic sequence. Because the error should in fact be an error of lists. I don't want to have to do conversions here, so we'll do it like this. Now let's see. If we go back into the tokenize, do we still get the errors? Yes, we do. Tokenizer result, string range character list. Result, string range string list. The type chart doesn't. Okay, let me think. I mean, does this need to be? Yeah, it needs to be a range string list. Okay, so this thing. Now, where is the any of? Oh yeah, here. This should be a character. I mean a string. This is a character and this should be a string. Now if we go back, let's go back to tokenize. Oh great, now most of the type errors can go away. And do we even need this spaces operator at the start? I'm not sure. We'll just get rid of it for now. And yeah, this is pretty good. I like it. Now we need to make this useful. And the best way to do that, I guess we'll move it down, all the way down, next to the macro. And we don't need, we can erase this because we already have it somewhere, yeah, right here. Maybe we could even put it all inside the macro. Oops, sorry. I'll just cut it. And then where's the macro? Oh, here's the macro. And now we need to start replacing all of this crap with something better. Okay, let me pause here so I can think about how we'll do this. Oh, the one thing that I missed while doing this is that we actually have two types of macros. The one that start with a quote and the one that start with a single, with an asterisk. So let's do something like yeah, this isn't too bad. So at this point we should start factoring things out. Let body C, and then just do this. This should be just body. Body. Oh yeah, now it will parse both types of macros, but we still need to figure out what to do here. So I'll go back to thinking. Okay, one more decision. I don't want the macro to be parsed when it starts with just a character. It needs to start with this $sign and a quote, and not just a $sign. So that will make things a bit more complicated. Okay, let's do something like this. In that case, we have the skip character. Do we have something like skip string? Yes, we do. Yeah, not bad. Let's see. Tokenize, skip string. We'll do this. We don't need the body anymore. It will be, actually let's do it like this. We'll revert all this and then we'll skip string A B. And this will be like something like this. We need to make sure to escape the inner strings. And yeah, I don't think we need to escape this small quote. Yeah, and this is probably the correct way to actually parse a macro in the Tokenizer. So at least the start of it. Now let me go back to thinking again. Programming is mostly thinking and not necessarily writing, so we can't really think properly without needing to write. I'm not really sure what I want to do here, but yeah, let's try just removing all of this. We don't need it. Great, now the code base is immediately better. How did I actually trigger the insert? I have no idea. Oh, maybe this could be it. I had no idea that you could trigger the insert by pressing Shift and numpad 0. Okay, let's see. Shift. Oh, it worked. Amazing. Okay, now before I got distracted, let's do what we need to do. We don't need this token argument. It was just for show. What we could do is maybe just fold all this stuff inside the macro function. We'll indent it, and yeah. Let's see. Parse macro. Yeah, this is it. This is a very good first step. Unfortunately, now it will complain that this is not actually returning what's expected, which would be a range and a token. Instead, it's just returning some weird whatever range spiral token list, and this is returning a macro list. The type range spiral token does not match the type macro. So we need to do something about that. And for starters, we need to include the ranges in here somehow. Okay. It would actually be a pretty good idea to include the range in the expression, because we'll need to adjust the token offsets. So let's see. In fact, like we don't actually even need this union type anymore. It was just there for simplification. So suppose we had okay, let's try. Okay, let me pause here and I'll show you what I mean. We'll actually go with the previous exercise where we had a token argument. And that would actually not be a bad design now, because in contrast to the code that we had previously for passing the macro here, this stuff we could very easily extend. But I decided trying to get fancy here would just lead to hard to understand code like we had last time. So it's better to it really is better to separate this into multiple passes. Okay, do we need this macro enum? I don't think we do. What we do need are the ranges. Now let's see. We have this string thing here, and then we need to put in the range, and we also need the range for this. Oh yeah, that macro enum actually should be macro expression. Okay, let's and as for this, we'll just overwrite it. Oh yeah, not bad. Oh, not bad, not bad, not bad. Okay, so let's let me think. Why is this? Yeah, this is like in the range. And how do we get the range? Well, the way to do it is to probably just maybe would something like this work? I guess it wouldn't. And that's how it works in the block parser, but over here, I'm guessing they're all getting the range manually. Okay, let's take a look at some of the parsers in the line parser. Now, what the hell is the range? This is the range. The result is a string, and it has a range string in the errors. I mean, is that really how it works? And they all have the... Okay, what the hell are these ranges? Okay, let's take a look at the quoted string. Where does the range come from for it? I mean, this is another complicated thing. Oh yeah, I have this inline f everywhere here, and that's what puts in the range. Okay, so that's pretty much the pattern for all of this. And I guess I wanted to really inline everything by hand to make it more efficient. But you know, the thing about the Tokenizer is that it's in fact the most efficient part of the whole compiler anyway. So I have no idea why I bothered optimizing it this much. I mean, this code works, so there's no point in replacing it just to make it more readable. The reason why we replaced the other one is because it isn't readable and we need to extend it. Okay, let's see. Let me think. Range. And it will take in a parser. And what's the actual type of this? Oh yeah, it returns an range and whatever is passed into it. So f equals f from, and now where are we using the f? F token string close. F token string close. And what's this L thing? Oh, it's a special character. Yeah, so the string gets separated. The string can have special escape characters, which need to be parsed. Okay, let me pause here so I can think about it again. Okay, I get it. Basically, all of the tokenizers over here need to actually return, the variables, the lists. And okay, this one actually get placed in a list over here, but they all need to return a range and a spiral token. And the range is separate from the token itself. I get it. Now, how do we implement the range? Well, it needs to take in a parser, needs to take in the tokenizer. Let's do it separately from everything here. So the initial range should be s from, and then it needs to run the tokenizer, and this will be the result, which gets returned here, and at the very end of it, it returns this s from, but it doesn't really just return the this like so. Because if the result is an error, it needs to be, this range needs to be tossed away. This is only the success case. So let's do it like this then. Merge ps with some, I mean not like that, like this. And in the none case, what should happen then? Oh yeah, no, not like this. It should be okay. This should be the error. Sorry about that. This is the error list, and I guess it should be like this. Does it need to be like this? Maybe. Yeah, this basically works like this. Let me just check the type here. The type in the string quoted, for example, on the OK case is range spiral token, and in the error case it's range and string. And in the errors we already have the ranges, so we don't need to take care of them especially here. Okay, this part is now, I mean the text part actually doesn't have a type error, so it's correct. And this also needs a range. Let's see, how could we do that? We'll put in the range here. And let's see, range and range. I guess this still isn't fine, so what's the problem? What is the problem? Oh wait, I've actually put it outside the parentheses. That probably isn't good. So it isn't, yeah, it shouldn't be bad either. Let me think. It's passing in the character. Oh yeah, I get it. Instead of this range here, we need to move it one scope up again. And that means doing something like, we'll wrap this all in parentheses, and we still get an error. Let me pause. Okay, I finally got it. It should be like this. You know, when parentheses start giving you trouble, you also need to start factoring out the individual expressions. I mean, I can only imagine how bad this would be if I was programming in a Lisp language. Yeah, this doesn't need a parenthesis. Okay, great. Now, what this should be returning, yeah, it's a proper macro. And now I think we finally need to actually process all the inner expressions. So we'll have to think about how to do that next. The first question we should be asking ourselves is, how do we even run the tokenizer? Okay, here we have this tokenized thing. It takes in a text, which is a string, and it returns a persistent vector and a list. Okay, what are these? What is this persistent vector thing? Persistent vector. Oh, does it split the string here into lines? No, I don't think it should be doing that here. Many iter. It iterates over a list of what exactly? I guess it iterates over tokens. Token S. Oh, it's getting passed into the. Oh, the tokenizer is getting passed into many iter as an argument, and then it gets passed into this list probably. And then what exactly? From 0, text equals text. Okay, 0. This is collecting the errors. Yeah, the reason why it needs to be like that, like this, is because why it's collecting the errors is because if we want to do semantic highlighting for the tokens, we're doing the semantic highlighting in the editor based on the existing tokens. So even if there are some errors in the tokenizer, we don't want to just throw away all the results. I mean, I'm not sure whether that makes sense. Okay, I'm going to have to pause to actually think about this. Okay, I realized something. I thought that this would maybe scan all the tokens, but it just scans a single one. Okay, that's going to be a problem. Because it doesn't really make sense to try to make this recursive. It only scans a single token, I mean parses. Yes. Instead, we need to tokenize based on this. And how will we do that? Yeah, this returns a list of tokens and a string list. Line token, persistent vector. Okay, let me pause here so I can actually think about this part. I had to lie down for a bit to think about it. Okay, first of all, this VS Code tokens, that's just for editor support. We don't have to think about this at all. And I'm not exactly even sure what it is for. I vaguely remember that something, and I think it's actually sending the semantic token legends to the editor, but I really forgotten what the line deltas were supposed to be for. Forget this. What we need to focus is this part here. And we'll, in fact, move it up. So something like here. And we'll make it a mutually recursive thing, like we had previously. And in fact, doing this after so many, I don't know, years, really did actually just today make me realize that this is difficult. I thought it was kind of easy. I mean, I thought it would be easy. And because I've gotten better, but I still that compared to web development, this is in fact way more difficult. I mean, I'm not really talking about this to brag. I don't really remember being this stressed out when, you know, doing a front end. Sure, the front end is time consuming to do, but it's not like I'm having such a difficult time deciding where to put the things and how to architect everything. I guess doing a language really is a good exercise. Okay, so now we have to pass the tokenize into macro. And now we have to actually do something smart with it. Okay, we have this thing now. That's a result. And yeah, we'll go over it. What the hell? Instead of, you know, what we'll do is destructure it right away. Okay, here we have the macro list. So far, so good. Now we have to iterate over it. And we'll, in fact, start things off by doing what we did in the old version. Okay. Now, where are these macro things? Oh yeah, macro term expression, macro type expression. I think I added this in the previous session, but then I didn't really know what to do with this. Okay, the term variable, type variable. I guess we will have to let this be here. So just so we can actually provide the semantic token legend at tokenization time. Regarding the semantic tokens that are getting sent to the editor, most of those can be determined at tokenization time, even without the parsing step. But a bunch of them are done doing the parsing step itself, because the tokenizer cannot really separate out the type and the term levels, except for these cases here. And these expressions, it will have to be like string open and string close here, and parentheses open and parentheses close. Because there are so many parentheses, we have these types to make them easier to deal with. Yeah, we can actually reuse the parentheses state for the tokens. Okay, and the token macro type, yeah, we can also make use of the same pattern. But I think we do have something like that already. If we go below, here we have the macro enum. Yeah, why not? Why not make use of this? Why introduce a new type? No reason at all to do it. Okay, now where is it? We just put this here. Bam. And now we can okay, macro expression. We can just do a macro expression. Of what is it? Macro enum and parenthesis state. Okay. We have the token macro open, token macro close. Where is the token macro text? I'm confused about that. Token text is this supposed to be it? I mean, what about the string? Token string open, token string close. Where is this getting used? Okay, in string quoted, where is the actual text? Yeah, this builds a string, and then what exactly happens to it? Range spiral token text to string, it gets turned into a string. It's a token text. Yeah. So this is what is getting used for the string tokens. It's not just a string token; it also has a closing and an opening token. Okay, and the special characters. Token unescape and token escaped character. Okay. So I really wish. I mean, we'll just look up the previous version, the one that of the macro function the one that I took, that I said was shit and erased, and we'll see whether it's using the token text or something else. Yeah, I saved it for a reason. Now let's see, macro. Okay, not this. Okay, now what about the text? Token macro open. Okay, yeah, I see it. Like with the strings, this the actual textual portions of the macro also get parsed as token text. It goes character by character, building the string using the string builder class, which in .NET is used to concatenate and append characters to strings. It's much more efficient than just doing something like adding two strings together. Whenever you need to add a lot of strings, use you should use the string builder in .NET. Now, okay, so we have this token text. Oh, no problem. Oh, I see that my username has changed for some reason in GitHub. Oh yeah, that's probably because I got a new PC, so the user data for Git changed as well. Maybe I should change it back to my actual name, but never mind that for now. I mean, it's not like it's a mystery who I am. Okay, let's see. We had we're going back into Tokenize. And yeah, and all of this we have to go over it. So we'll do a fold. Let's assume from where we left off yesterday. This is actually, yeah, it's a pretty tough problem that really surprises me. I've never had to really think so hard during web development. And after thinking about it for a while, I understand what needs to be done. We're going to make the macro tokenizer a part of this recursive block. Let's do it right now. We want to need this argument. And this is how it should be. Now, we need to also get rid of the argument here. And now we have something that's a decent starting point. The only problem is that we are going to have to call this tokenize recursively, and as you can see, the return type it returns a persistent vector of range and spiral tokens, and the errors are in the separate list as the second part of the tuple. So unlike the token, which either returns a result which can either be an OK or error, the tokenize doesn't actually have such a rigid delineation of successes and failures. It instead returns both the successes and failures. So if we start using tokenize inside the macro, we need to also return the type that's returned from the tokenize. And if we return the type that's returned from the tokenize, we also need to return the same thing here. Meaning all the other tokenizers need to change in order to accommodate that. So here is what we could do. We're going to get rid of the macro here. This part is basically decent. We also, okay, let's name these individual tokens. I know I'm supposed to be pausing between the stuff that I'm doing and explaining as things go along, but it turns out it's actually a lot harder to do that when you don't know what you're doing yourself. I mean, as I write, I'm figuring this out myself, so I have to play it as I go along. Here we'll do the individual macro. Macro equals macro. Yes, but it won't just be this. We'll have to convert it to a type that it can be returned, that can be passed directly into tokenize, so it matches its own type. So let me pause here and I'll figure out how that could be done. I did a bit of work today, and you should be able to see what I'm trying to do. From here on out, the token will not return just a either result, which is a list of tokens with their ranges, or errors. But the success case will also be able to return an error. This indicates that the parser had succeeded, but it had some errors, for a lack of a better word. And the parsing can continue on to the next token. Inside the Tokenize, we'll be able to make a good use of that. So what's needed to be done is to resolve this type error here, which I'm not really sure how it is. Basically, let's in situations like these, what we need to do is provide the type, and this one should be it should be something like a list, and range, and the spiral token. And this thing should be, let's see, it should be a list of errors. Now let me think. Okay, I understand what the error is. It's kind of this type error is really hard to parse. But if you look at the bottom line, you'll see that it's complaining that we're giving it a nested list, and it's expecting a pair of lists. So that's the issue. Okay, let's do it like something like this. And really, I mean, this shouldn't really work. Range, spiral token list. Yeah, we need to flatten this particular thing, this error. We also need to save the errors in a list. Okay, let's do all this step by step. We have the argument here. What we need to do is that list iter fun x let mutable here. This will just be an empty list for now, and what we'll do is append it to error. List append. Let's see. I think this one should come as the last argument, and oh yeah, the inner ones. Let's name it a bit differently. Oh yeah, not bad. I'm kind of wondering whether this function has something to add a range to the persistent vector. It probably most definitely doesn't. Persistent vector. Oh yeah, it can only append the two persistent vectors. In case you're wondering what this persistent vector thing is, it's kind of like a mix between an array and a list. It's made of list cells, actually a tree of listed cells under the hood. And it's an immutable data structure. If you Google the persistent vector, you'll find it online. I think it first was invented in the standard library of the Clojure language. At least, you know, I mean, it's probably an academic thing and got invented way before, but that's when it first rose to popularity with the Clojure language. Then it spread to Scala, and I found it in an F# library, and it's pretty useful. It's much more efficient compared to using a list for appending and prepending elements. Okay, let's see. Okay, this should be list append error. Whew, okay, not bad. Not bad at all. Now, what exactly should we do? Yeah, this many iter, it's very similar to the many combinator. It just iterates the token parser here and many times. And it's really much easier to just append the stuff to an array in an imperative fashion like this than try to mess with trying to make a fold function out of a combinator. It's a waste. It would be a waste of time. And if you think about it, what we did here is basically a fold function. It's just how it would look under the hood. Oh, not bad. Now, okay, these are tokens. Where are they getting used? Oh yeah, here. Okay. If we clean it up just a bit, it's more readable when it's put on the same line like this. Now let me pause for a bit so I can think of what comes next. I think with this we basically do have the tokenizer done, and yeah. I understand what we have to do. Oh, this thing. I forgot about this. This needs to go away, and we are missing a case here. And on that note, we are no longer using this macro term vars, even though we should. And we're going to have to add them to the macro parser. We'll do that right now. Let's see. Case var. Yeah, this one isn't very good. Instead, what we need to do. Okay, here we have the body, but we also need whether. Yeah, basically we need to go through all the cases and make sure that it uses the relevant expression, or rather a case for the individual macro variables. That will. It's only a very minor advantage, but it will allow the type variables to be have the correct semantic legend tokens during the tokenization phase. Regarding this, here is what we are going to do. You'll probably find this technique interesting if you haven't thought of it. Here's how you can you can in fact just return a function from this parser pipe operator. And I'm not sure how to call it. It's just a pipe ring. Okay, now we'll move that into, yeah, okay, we'll do it like this, and we'll also copy this argument. Whoops. Yeah, like this. Now we also need it's okay. It seems like it's not. Why is this not star character and the body? Oh yeah, it also needs a star character here. Okay, let me pause for a bit. Okay, this is roughly closer to along the lines that I envisioned it, but we are still not applying the range to this inner function. So we'll do that right now. Yeah, not bad. Now this here returns a macro. And instead of, in the case variable, instead of having this expression, we also need to make it a variable. Range string macro enum. Yeah, not bad. We'll make this a private type so that the other modules cannot import it by accident. We're only using it internally anyway. Oh, now let's see. Yeah, we still haven't actually filled in the cases here. This is where we have to call the tokenizer recursively. But yeah, also we need to change this to var. Now, I'm thinking that maybe there would be ways of doing this a bit more succinctly. Okay, let's, as an exercise, instead of having to copy paste start here and then having this big chunk be mostly the same, can we actually factor this out? I'm going to pause here and try it and post in the comments whether your opinion, or rather your prediction, matches what I did. And here is the solution. It's one possible approach to make things more elegant. Now we aren't really doing anything unnecessary in the case parent and case variable. We only have the parsers for the relevant thing, and they parse the body. And they return a function that takes in a starting character and a range, and only then they result in an expression. This function that they return is being applied right here with the starting character and the range. So far so good. You know, I'm a bit tempted to maybe organize this like, you know, so. But even though it's like 2 lines less, I do think it makes it a bit less readable. But who knows? Never mind. Let's leave it like this. It's very easy to factor out if we need to do so later. Being able to, you know, inline the variables and factor them out is a core skill for a programmer. And now we need to take care of this. This is where we'll call the tokenize function recursively. Let's see, we have the range, we have the string, we have the macro enum. So what will we do? Oh yeah, let me just check out the types that we set out. Okay, here we have macro type variable, we have the macro, the token macro expression. We need to oh yeah, this could have this could be nested, and they need to start out with the type. Okay, I see. Okay, so how will we do this? Okay, for starters, how about we do it like... Okay, well, what's this thing? It's a list of macros. Oh yeah, okay. Instead of using the map function, there is a function that actually concatenates all the stuff, all the results. I think it's is it choice? Is it choose? No. This one takes in an option and does filtering. Instead, okay, we'll go over all of them. I cannot really. Oh yeah, it's collect. Now this part needs to be a list. And what this will allow us is to return multiple results from the expression here. In fact, before we just move on to the expression, let's just take care of the var case rxt. And this one takes in a macro enum, so let's just do all the cases right here. We'll destructure them in place. M what? M type, M term, M type lit. I'm looking at it on line 346 as a reference. M type. And this should return what? Toc macro type variable. And this should be like X. And this should be like R. And once you have this like first case, you can just copy it a few times and then take care of the other cases. Let's do the type literal. Oh, it's type literal variable. Okay, and this should be term. Oh, not bad. Oh, now for this, we need to start things off with the starting token. Okay, let's make this start, and this should be. Okay, this should be R token macro. Yeah, macro expression. And it needs to be a macro enum, and this should be like parenthesis state should be open. So what exactly should come here? Okay, what's the parenthesis state? I'll place a bookmark with control key, and now let's just not Google it, but do a quick search. Oh, so it's open and close. Okay, you can go to the bookmarks in Visual Studio with Control K and N. Now it's put us in a completely different file. Okay, now we're back, and it's in fact what it should be. Let's duplicate this once and we'll make it close. And I'm not sure whether this range is really correct, because we're actually taking the range for the body instead of for the opening and the close. So the way it should be is a bit different. There should be like something like range character. Okay, let's do range character. And if you look at what this does, I think it takes in from, and then it's just a single character. And in fact, this should be like, this should go like 2 back. And okay, let's do it like this. We have to take care of when passing the range. The range is okay, from equals r from -2 near 2 equals r from. And now for this, what we need to do is make the range on the opposite end. Let's see. The from should be the near 2. And this should be +1. You understand why this is the way it is, hopefully. The reason why this is like so is because the introduction token is something like I mean the starting token is something like, let's see, grave, and then so this the range is this thing inside here, and then in that case the start should be something like this, and this is what this R calculates. And actually this is for the end, sorry, and for the actual end, this is what this R calculates right here. I hope that makes sense. No problem. Now we also need the middle. Let's see, how do we do that? Let middle. Yeah, here we first have to call tokenize. Yeah, tokenize takes in a text, so that's X. And then it also takes in, yeah, it doesn't actually take in the environment, this thing here, the tokenizer itself. And yeah, now we have a list of errors here, and a persistent vector, which is like similar to a list. And well, what's the problem? Well, I guess we also have to turn this into a persistent vector, or rather we need to prepend the start and append the end to it. So suppose we did it like this. Let's all, then we do a persistent vector, and then prepend conj. Oh yeah, this adds it at the end, and it has something like j. What's the opposite of cons? Let's see. Cons. Oh, unconj. I think this is a throwback to Lisp. So, oh no. This actually just returns the last element. Okay, let me just pause for a bit here so I can figure this out. It seems that I remembered it incorrectly. I could have sworn there was a method to add an element to the start of the persistent vector in O1 time, but it seems like there isn't. I even asked Bing, and it's telling me to basically make a new vector and then, you know, to make a new vector with one element at the start, and then just append a new persistent vector to it, like you would for a list. Okay, let's just oh no, where is it? Okay, let me pause. Something like this. One thing I've realized is that I got these ranges wrong. If you look at how it actually works in parse expression, or rather, no, where was the range? Oh yeah, it's right here. It actually wraps everything around between the start and the case paren. So the explanation that I gave earlier was in fact completely wrong. I don't know why I just assumed that it only got the range from the inner stuff. Instead, what we have to do, the from is correct, and we need to add a +2 here instead, and the near 2 here is correct, and we need to add a -1 here instead. Now it should be correct. Now, okay, we have the persistent vector all, we have the errors, and I guess, do we need to return this? Is that how it works? Okay, so this list should actually also collecting the errors instead of just the tokens. How will that work then? Okay, let me pause here so I can think about it. Okay, here's how we're going to do it. First, let's take care of returning the errors here. For these 4 cases, they'll just be empty lists. And we can just pipe this into OK. And now, unfortunately, the collect won't work. So what exactly will we do? Whatever, let's just do a map here for now. Then we'll do fun x. Whoops, not like that, but we actually need to separate out the errors. Or maybe we can just okay, 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 we'll unzip them, even though it's kind of wasteful to do things like so. List concat L. And now, what exactly is the problem here? Oh yeah, we also need to concatenate these. Okay, here's one way of getting the errors, but there is a more efficient way of actually doing it, which involves doing some imperative programming. I'll show you how it could be done. We just do let error here, we make it mutable, and then we go back to collect, we added the error here to the one in the outer scope. Oops, we're at the dash. And yeah, what's the problem here now? Range string list. Range string list. Oh, this value. Oops. Sorry, I've been assigning it to the wrong one. Thank you, Fsharp's type checker. Now we have the all here, and instead of doing this completely wrong, we'll remove it. Then we do a start. Then we concatenate that to the middle, but we need to actually turn the middle into a list. Let's see, of sequence, and then we put in the end, I think. Okay, let me pause here so I can figure this out. Okay, I figured it out. Basically, we cannot do this thing that we're doing at the end, unfortunately. Okay, let's do it like this then. and this will be list of sequence. I'm just wondering whether the persistent vector, oh yeah, it has two sequence. No, but it doesn't have two list or two array, so never mind. And now we'll just convert this all. Okay, but let's first put it on the same line, so it's more readable. And now what we'll do is do a list concat, and that will flatten all of these into one single list that we can use here. Now we're getting a complete list here, so we don't need all this. I mean, you might wonder, is assigning the error to the error like this a good practice? I'm guessing it's not, but you know, this is kind of done locally, and the Tokenizer is a very frequently used place. So you know, a tiny optimization like this won't really hurt. Now what's going on? Okay, now we have the macros, but we still don't have one very important thing. When the Tokenizer actually calls the token, now where is it? Oh, here's the token. It passes in, it creates a environment, which is this thing, and this record starts at 0. So all the tokens will have will be starting at 0 instead of where they should be starting in the actual text. And that's a big problem, because the semantic tokens will not show up in correct places unless we give it the correct ranges. It will end up being garbled. So what we actually need to do is also go over all the middle and process it, so it adjusts the offsets inside of these ranges. The same goes for the error here. Now let's do that. Adjust range. Okay, now this is a persistent vector, and this is a list. So okay, let's make this just for a single range. And what we need to do is actually pretty simple, and that would be to do from equals r from plus first start from, or actually no, it's first start near to. That's this near to will be the character that's past the opening quote or the parentheses, and that's exactly what we need to start things off. We also do near to equals r near to plus this whole thing here. Oh, not bad. Okay, now what exactly do we... Yeah, now we have to actually make use of this on the middle on this error thing. So let's do that. Let middle for fuck's sake equals... Okay, let's do it like this. And that will be list map Okay, this one is for the error. We'll copy this adjust range, and then we just pass the error into it. And we also need to take care of the middle. And the middle would be persistent vector map. Whoops. And the middle. Now, what is the problem? Oh yeah, it needs to actually be the first. Whatever. Well, we can just do it like arrange. Yeah, no problem. Now. Okay. We also need to return the other part. Rx. Let me just make it x. Basically, this is how you build a whole compiler, except it takes you like 3 years to do the whole thing. You make many small improvements, you iterate over the design as you go along. Compared to larger languages like Python, where making a single change is a big process, I'm in control of everything here, and I can make the language do whatever I want. Oh yeah, no problem. Do we still have maybe a type error somewhere? Let's see. Okay, so it's missing a case here, and that will be token macro expression. Oh yeah, that's basically just the opening parentheses along with the prefix. So took macro expression. It's also the closing part. That will be what exactly? Macro in parenthesis state. Whatever. We don't need to actually take a look at what this is. Instead, what this should be is, do we make it a keyword, or do we make it something like just a string, or do we make it maybe a symbol? Do we make it a parenthesis? We'll make it a parenthesis. Okay, token macro. Now I think I'm just curious. Wait, I think yeah, the token macro had also an open and a close. Oh yeah, token macro open, token macro close, and where is that? Right here, and it's a string. Oh yeah, that's not really a problem. We can just we'll just leave this as parentheses, and who cares? Now I think we actually don't really have any type errors here, but it's not the case that we're done. We definitely need to do some work in the parser itself, so it actually parses the new tokens, and we have to work on that next. Now let's see. This is in the block parsing, and now where is it parsing the macro? Case macro, script macro open, many read text, read macro variable, and it produces this raw macro AST node. Okay, we'll first place a bookmark here, and if we look at the read macro variable, we have this. And what we also need is to add a case for macro expressions. And that thing here, I mean this thing, no, not this, but this thing here is the macro parser at the term level. There's also one at the type level that we will have to take care of as well. So we probably have to factor this out. Okay, let's factor this out. Oh no, where's the parentheses? Okay, let's make this at the body. Oops. Okay, now we will have to add another case, something like this here, to read the macro expression. This doesn't really exist right now, and we're going to have to implement it. And we cannot just read an expression. We have to read everything between an expression. So, in fact, what we need to use as a reference is the parentheses parser. Okay, the record parser is a bit complex, so we won't use it as a reference. But where is, oh yeah, case rounds. This is how the parentheses parser works. It just parses everything between the parentheses. Now we'll bring this down here. I mean, and we'll comment it out. This is just supposed to be a reference. Now what we have to do is look at this and really think how exactly can we bring this into here. The functionality from, how can we take the functionality from here to bring it into the case macro. We're going to make a commit here, and then we'll only resume this after breakfast because it's already 12:50 p.m. The next is the in the block parsing module. Oh, okay. No, not bad at all. I don't know if you noticed, but lately I've gotten a standing desk, and it's really helping me during the actual day. But my nights are much worse as a result, it seems. So I'm going to have to, take a break in the nearby future. But I'll at least get this video out before that. Okay, save and commit. Okay, did it finish? Yeah, it's finished. Okay, let's take a break here and we'll resume after that. See you in a few moments. Oh, let's finally resume. While I was resting, I had time to think, and I realized that we missed a huge thing in the macro parser, and those would be the special characters. I have no idea how I forgot those, but it happens. By special characters, let me show you what I mean. So that would be something like slash and n. As you can see, this isn't brown but white, which indicates that this is an escaped character. And there are also unescaped characters, which are like slash and something like that. Basically, they're anything other than the special characters. And if I look at this one is a bit yellow compared to being pure white, which indicates that this is an escaped character. And yes, the macros need to have those. I think you can also escape the gray and the gray, the bang, and the slash. If I do this, yeah, it escapes the bang. Suppose I do this. Yeah, that's also one of the ways of escaping the gray and the bang. But I'm just wondering, is this translated into a single character or two? I'm not sure how it was done in the parser, but never mind that for now. Maybe I'll get rid of these double, these double characters, since you already have the same functionality by using a slash. For now, let's just focus on parsing these special characters. Now, let's see. We are in Tokenize. Where's the... Okay, here's the parsing of the text. Okay, now that we've come this far, let's rename these to something better, like pvar. Usually I like to use a snake case. On a regular keyboard, this is a bit hard to hit, but I have it. I have the underscore keyed to my shift key, so it's kind of easy for me to do. Okay, we have it renamed. Now we have to go into the parse text and also add the special character here. C not equals oops, I'm using the wrong why am I getting the error here? Oh yeah. You also need to escape it in .NET code. This will get translated to a single slash. Okay, now what do we do? We are not parsing the slash, so we need a parser to actually parse it. Now we need a case special character. And as one consideration, we're actually going to put that as the very first parser for reasons that I'm going to explain. Oh, now, okay. Okay, this is parser for... Wait, this is a parser for expressions. Oh yeah, so it's the parser for all the expressions. Okay, let me just pause so I can think about it a bit more. Actually, I got it wrong. We shouldn't be putting this here, but instead, where I meant to put it is here. And the reason why we want to put this in the first position, what's really important is that this parser gets tried before the expression one, because when the expression one parser makes an attempt at parsing the text, it will first begin with the start parser. That's the parser that parses one of the three special characters. The ones under the cursor here. And once that happens successfully, the parser state will get moved forward by one character. So, and in that case, these alternative operators would end up resulting in a failure. But if we try this special character parser first, it will only move the parser forward if there is a success. And that will avoid having to run into an error had it been in last position after the parse expression. So let's do this thing. Let be special. Now let's see. Can we get the special character parser from somewhere else? Character quoted, string raw. I actually forgot that Spiral has raw strings. Okay, let me pause here just so I can find the code for it. Okay, here is how the special character is parsed in this thing here. So we're going to have to do something similar, most likely. Okay, we have the new line, the carriage return, the tab, and the backspace. I mean, I pretty much never use any of these apart from new line, but since languages have them, we might as well put them in. Okay, I'll just copy paste this as a reference. Now let's see. And I'll comment this out now. Okay, so we need to parse. Okay, let's peek at the top two characters. Peek. S0, S1, match with, and okay, so first we're looking for a slash, and the second character can be one of the four. Let's see, new line. I mean, I'm not going to copy paste everything, but just this four. So we can actually match on them like this. Let's see. R T B, and these are the escaped characters. If we find one of these, we should just return an escaped character token. Let's see, token escape character, and the character is as. Oh yeah, not bad. And the other cases are unescaped, I think. And anything else is an error. Let's see. Okay, let me just pause here so I can figure out how to do the errors. Oh, so something like this. I'll copy this. Now, where do I put it? Oh, didn't I copy it? I guess I didn't. Okay, and we are looking for a slash. Error character from, and yeah, this returns an error like this. And okay, so, but now it's complaining that probably that we don't have the range. So we also need the range. And we'll put it in. So let's see, how do we do the range? I think it was like here. Range character, error character. Okay, range character I. Oh yeah, we also forgot one very important thing. We need to actually, if the parser is successful, we need to increment it. Otherwise, it will just stay in place. What is this? Oh yeah. Okay. We'll just do it like this, and oh yeah, we need to get the range before we actually do the increment. Error car range character, range car s from, yeah, not bad. And I want to put all of this on the same line, but you know, it's not. It's kind of, it would be awkward. I just do it like this. And now, yeah, we have the parser for the special character. And why do we still have the type error here? That's what I'm wondering. Wait. Yeah, this is a success. And range spanner token, range macro. Oh yeah. We need to return actually a macro. I mean, do we even need to put in a range here? I'm not really sure. Yeah, we need to actually put it into the macro. Oh boy. Okay. I guess we'll extend the macro. This is text. So it doesn't have to be a string. It can be a character. Okay. Let's make it escaped character. And we also need unescaped. Oh yeah, okay, this is pretty good. And okay, instead of we'll be converting it into token escaped and token unescaped in the latter pass somewhere here. But for now, forget it. Let's do okay. This should be escaped. We need to put in the range. Unescaped character. We need to put in the range. Now if we go over here, we can finally add the missing cases. Oops. Okay, let's do it. I'll pause it for a bit. Oh, this is how it looks like right now. Not bad, right? And this is in doing it like this in like 2 passes is a lot better than doing it in a single one. It's much easier to understand. I think I should have, you know, created the whole tokenizer like this, but I didn't. Arguably, it's a bit less efficient than the original, but that isn't really something that matters in this case, because as I said, this tokenizer is the most efficient part of the whole compiler, and even if it was slower than 2 or 3 times, it will still be the fastest part. And the main reason is that it works on a line-by-line basis. The block parser, which does the actual parsing over the tokens, has to parse the entire block again on every change. The same goes for the type inferencer. But the tokenizer, since it works on a line-by-line basis, when a user makes a change, he only needs to, it only needs to retokenize the individual line. That's why it doesn't really matter what its efficiency is. I guess the only time it matters is on the initial pass. But macros in general won't really have a lot of these nested structures. They have to be on the same line, and if they get longer, the user will break them up into individual functions and such, rather than cramming them all in a single row. So the fact that this is kind of doing a lot of heap allocation, it's allocating a lot of intermediaries. We are converting the persistent vectors to lists and then back. It doesn't really matter. I probably should have used the Fparsec for this whole thing instead of writing my own parsers, like here. Well, it's not like there are many of them. Okay, I guess it wasn't really a big mistake to write my own. Like 100 lines for a project such as this is not much. And maybe just this one. I think it should be actually in the parser combinators. I was actually surprised yesterday to find out that they work on both the tokenizers and the block parsers. I completely forgot about that. And the reason why they're generic is because we're using this let inline, and we are calling functions. We are calling member methods on objects using static type parameters in F#. It's an F# feature that allows you to pass in a generic object and specifically call, for example, over here, the index member on that particular object in a very generic fashion. Okay, let me just... I'll put this like so. We'll also put an inline here. Generally, function inlining, accidentally pushed on my trackpad. What I meant to say is that generally, inlining really benefits when you are passing your functions to other functions, because in that case you can kind of avoid heap allocating them, and everything becomes more efficient. Beautiful. This is basically how you can write a generic parser combinator library. The reason why I couldn't use Fparsec, as I mentioned, is because it only works on characters and not tokens. But this one is perfectly generic. It was specifically made for the spiral language, so I didn't put any comments here. Maybe it could be spun off into its own individual library, but I see no need for it right now. Let's get back to tokenization. Okay, the between still works, no problem. Okay, we have the escaped characters. Oh yeah, we still don't have the thing that I showed you. I'm going to have to look into the history to really check out whether this ends up being a single character or two. Let me pause here so I can do some research. Oh, and before we even check that out, I've just realized that are we even putting token open and token close anywhere? Because that should definitely be in the code base somewhere. Okay, token macro open, token macro close. That's what I meant. Oh crap, yeah, we forgot about that. That is, I'm the one who forgot. All the mistakes are mine, and all the benefits are ours. Let's see. Okay, we need to parse the very outermost. We need to put that in the very outermost macro. Okay, here we have the macro. Here we are also parsing the body, and it's between the skipped characters. And yeah, we actually need it's returning a macro list, and we don't need to put the open and the closing tokens. Otherwise, the parser either in the latter stage won't know what to do. So let me think. Okay, here's how we're going to do. Well, starting off like so. Here we have the range. Now let's do the same thing that we've done in the start and the end. Actually, let's copy these two. We'll copy paste them. And instead of returning this token macro expression, it's token macro open and token macro close. Now we have the start and the end, and we just need to plug them in here. So something like list concat start. Okay, L and then the end, and we'll wrap this in a list. I don't like how in Visual Studio now you can just, you know, press this and it will put the parentheses around an expression. Previously I had to, you know, select everything, cut, and then put in the relevant parentheses. Okay, I guess this would work. Now the macros do have a start and the end, much like the expressions do. Oh, okay, now what do we do? What do we do? Yeah, I think, oh yeah, we also are missing that, you know, 2-character bang pattern. I keep getting sidetracked. Let me go back to what I was doing. I'm going to pause for a bit. Here's how it was before. As you can see, it parses these special characters, but it also does this thing here where it picks at the follow-up character, and then it decides if it's, you know, the same. Then it appends the current character to the string builder, and for that reason this is why they aren't getting unescaped. And after some thought, I've decided that I'm actually going to forget about this. We are going to change the semantics of the language so that you know, the bang bang let me just, as I was saying, we're going to change the semantics of the language so that bang bang and et and gray aren't treated specially anymore. Instead, if the user wants to write a bang in a macro, he can just use a slash like this. And this will be perfect. In addition to that, I'm going to go an extra step in changing how the language works. And you'll remember that the language has something called this $v pattern. It's generally used in the code generators. And instead of doing it like this, we're going to use the /v. And instead of this printing v, this is going to be treated specially in some code generators in order to actually unescape a variable. And the benefit it will have is that during syntax highlighting, it will show up as, I think, yellow. This will actually make it a lot more visible. So I'm going to make this change pretty much everywhere. Let's see. Find in files, find all. And okay, this readme MD, I'm going to have to change that in VS Code, because the VS Code has an extension for making the table of contents, and whenever I change the header, it will change the contents automatically. So let's do that. Let me pause. Oh, sorry about that. We're going to make the changes in the libraries and the documentation after you actually make the change. Now let me see. Not in this. We're going to change it in all the code generators, and in the code generators it will actually be pretty easy, since there's only one spot where it's actually escaping the v. Now let's see, where's the next thing? You just go over all the actually, wait, how will this, unescaped character even get printed in the time macro? Like, okay, this will be a bit complicated. So I guess I'll need to output it specifically like this, but keep around the slash. I know what I want in the program itself. I want the user to just be able to write slash and then v. But once that gets translated into a macro, how will that end up being? It will be a pretty weird case if I think about it. Yeah, I'll just let it be as slash v. Okay, let's go with this. And okay. We'll also modify the error message, and in fact, I forgot to put in like 2 slashes in the previous thing. We actually need oh, there is also I need to make sure that it's escaped in both places. Okay, now let's go over all of these. Okay, I'll pause here while I make the changes. In the code generators, there aren't actually, as I said, that many places where this needs to be changed. But if you do something like a search or a library, you'll see a huge amount of changes needed. If I do this automatically, there's always a risk of making a mistake, but it doesn't really matter to me. We will run it and test it out that way. We'll make the changes later. For now, let's get back to the compiler. Okay, let's see. we made the changes like this. I'll close all of these. I'll close the history. And now, okay, we have the special characters. Do we need to treat? Yeah, we need to also treat v in a special manner. Or rather, we'll actually make the change in the parser itself. You know, we'll just put in the v here, and then we'll have to remember in the parser to check whether it's v, and then we'll output it as a /v in the resulting macro, so the code generator can actually find it there. So now, what do we do? The three patterns for before we won't even have, and I'm pretty sure I'm using it nowhere in either the examples or the library or the core library. So it won't be a big loss. And now I think we can actually start working on the macros, on the macro expressions. Okay, let me pause here. Okay, I made the commit, and now we can get started with this. And what we want to do is actually study how the macro works before we do anything else. We'll leave this as a type error. Let's think about this for a bit. Okay, I guess this is to combine the ranges. And this is the parser going over the tokens. It has a string builder for the text. It just appends them together. For the escape characters, it also just appends them. And it's not really a big deal because to have the escape characters in the text, because we already have the semantic tokens during the tokenization phase, and it's unnecessary for it to do anything else with them during the parsing phase. But now that we have the special v macro, we're going to have to do something special with the /v. And what exactly do we want to do here? And do we want to do that pretty much anywhere, or because I think this function is also probably used in strings. Yeah, it's read the string. So if I do like a special case for escape character of v, it's going to be problematic. Okay, instead of having it be an escaped character, why not we add an extra token and have it be an escaped variable? I mean, what's the problem with that? There is no problem. It's just too complicated to mess with the parser. I don't want to touch the way the strings are being parsed and so on. Now, okay, let me think. This is the escape character. We're going to do a special case for v. And it actually doesn't need a character. Okay, this is the escaped var, and we also need a token escaped. Let's see, where is it? token escaped. Where's the escaped? Oh yeah, here's the escaped character. Oh, okay, perfect. Now we have this here. Oh yeah, I forgot something. I need to put in which group the escaped variable is. We have the over here this tokens group function, token groups function. It takes in the tokens and maps them to the semantic legend, which is an enum, and this is defined all the way in actually, let's load the other project, the VS Code plugin. And if you look at the package.json, we'll have the semantic token types. And we have the IDs, symbol, the unary operator, the ID, and there's also something, there's also a mapping for them in the index.ts. Let's see, legend. Yeah, here they are ordered in the way they appear, and this is being mapped. This is mapping the tokens to these semantic token legends in here. And what we have to do is add the variable, and yeah, now it will get treated as an escaped character in terms of editor highlighting. It will probably show up as yellow, I think, and it won't really clash with the other escaped characters. Now let's see, is this it seems I still haven't added it. Okay, let's do that now. We'll select this and we'll go over here and oh wait, why is this giving me problems? Yeah. Okay, great. Now this is fine, and we actually need to convert this case. I mean, handle it. Okay, let's see. Escaped var. Okay, perfect. Now what we have to do is in the block parser. Over here we don't need to handle it anymore, but what we have to do is probably handle it in some parser. So let's see, we have the read text here, whatever. Let's just okay, let me pause here so I can think about what I want to do here. Okay, I think I know what I want to do, and we're actually going to get a lot more fancy. What I'm going to do here is add another semantic token type, which is escaped var. And we're going to add them to the list of semantic tokens, like in package.json. What is the change? Oh, I mean, it doesn't really matter. Let's just now we have the escape variable, and this is a super type. It really is what determines the type of semantic highlighting, and that depends on the style. With for example, the keywords for TypeScript are await and let and const and so on, and we should maybe paint the escape variable as like something else. Member operator. I mean, these types are all pretty much fake, but I don't know. But it isn't easy to actually style them otherwise. I kind of regret not putting more effort into figuring out how styling works in Visual Studio Code. Okay, we'll let them be something other than the the escaped character, which is yellow, or the unescaped one, which is white. I guess there'll be purple or something. Yeah, there'll be purple. Oh, okay, so far so good. It makes the sense to make this change. Oh yeah, we also need to add them to the tokenizer, so they own their own semantic legend. Let's see, semantic token legend 13 escaped var. Oops. And now we'll just actually make use of it. Let's see, we have the escaped var, and we just put it here. And now it will get assigned the correct semantic token type. And if you go into, for example, Visual Studio Code, like here, and open the control palette, you can actually find the inspector for the editor tokens and scopes. Oh yeah. I clicked on that, and now you can see how this window is showing open. You can see for the fun here, the language for some reason is blank, standard token type is other, and the semantic token type is the keyword. And here's the color, and I have no idea what all this stuff is, but this is basically the semantic token type. If I go into a comment, indexes into an array, this whole thing is a single token, and it's semantic token type of a comment. And this is really convenient because I don't have to create my own styles for the language. Instead, the styles are based on what you see here in the in the preferences, and you have the themes, and you can actually change them however you want, like dark Visual Studio, ABs. I kind of like this one the most, I think. The styles are what actually give the color to the tokens. So, okay. I should at some point dig into these styles and see which exactly tokens they support. Maybe I can give some more color to Spiral. Now let's get back on track. We have the escape variable here. Now we are in the block parsing, and we are in read text, and we are considering what to do with it. Well, I changed my mind on not touching this. We'll add a flag here, is term macro. Because this is in fact the ideal place to actually do something about the escaped variable. And yeah, we can tone this down like here. And let's see. VSC range. I guess it's keeping the range. And it will append to the string. Yeah, it will have to append what we've been talking about, / and then we. And all of this will be a part of the macro text. And now what you have to do is go over all the places where this text is used and pass it to false. For example, this is reading the strings and it's not a term macro, so it doesn't need to handle the escaped variables. The one thing that I forgot is to actually make use of that thing. when is turn macro. Now, if this is true, this case will trigger. But for example, if this was false and the token was token escape variable, it would result in a parsing error. Oh yeah, we can also add an extra error. Okay, let me pause here for a bit. Oh yeah, I understand how I want to take care of this particular error. We're actually going to pass the isTerm macro into this, and then we'll do a search for where this is getting printed. Okay, now we'll do a peek to change the type. Let's see. Peek definition. It's not just any escaped character. Expected escaped character. And this will take in a boolean, and we'll put in a name just so one can understand what this boolean is for. isTerm macro. Okay, isTerm macro. Okay, false, and this will be true. Escape character or V. Okay, not bad. Now let's see. Let's get back to what we were doing before. Yeah, now the error handling is also impeccable as well. Now, what do we want to do? What we want to do? Yeah, basically I think we have, we also need to cover all the other cases. This read the text is false since it's not a term macro. This is the macro parser, but in the type, so it's also a false. And the one other place is here, and this is true, and we no longer need this. Oh yeah. This actually read the special characters inside the macro right now and the escape variables, but we still need to do the nested macro expressions. We have to make up a parser for that. So as we said a while ago, we'll use these case rounds as a reference. And we need to figure out what this rounds thing is doing. How exactly is it reading the stuff between the parentheses? Let's see. Okay, we'll go into this. Skip parentheses, round open. Okay, so this is how it works. Okay, and we need a macro expression. And we also need the type of the macro expression. Okay, let me commit here. I'll pause for a bit. Okay, now we also need something to skip the macro expressions. Let's see. Skip yeah, this takes in a parenthesis state and a parenthesis. And this thing should I guess I wanted to actually pass the macro type into the parser. That's something that needs to be done. Okay, but for now let's just prototype it. Skip macro expression, and we have this ABD. The D is the environment, so it's kind of unfortunately named. Let's see. Token macro expression. And we have the macro enum and the parenthesis state. And yeah, this would skip the current token. And yeah, this means it can parse the macro expression. And if it's something like a term expression, it needs to run the term parser, otherwise it needs to run the type parser. Skip a macro. And we need, for the macro expressions, we also probably need some kind of, no, actually we don't. We have all that we need already. Okay, let me pause here so I can think about it for a bit. Okay, I've decided maybe there is a better way, but for now we should just imitate what we have in skip parentheses. So that means we'll just do this. Macro expression. Okay, we have this, and of course this case doesn't exist, so we'll create it. Oh no, where is it? Where is it? Where is the peak? Here it is. We'll duplicate this. We'll copy paste this. I really like how the peak works in Visual Studio. It's better than, I think, in Visual Studio Code. So I can't really even remember ever using it in Visual Studio Code, and that's probably because I never program in F# in Visual Studio Code. The AI plugin is generally inferior to what you find in Visual Studio and the Rider IDEs. And the reason for that is that the AI plugin has trouble loading projects sometimes. A lot of the times for me it simply gets stuck when loading a project, and that ends up wasting a lot of my time. So I don't like to use it except for scripts. Okay, now, oh yeah, this should be a macro enum. Macro enum. Okay, now we have the skip macro expression, and we'll do something like macros. Macro expression AD and what we'll do is change this a bit. Instead of okay, you know, usually I'd try to abstract everything, but you know, whatever, we can in fact just no, we will abstract it, even though we haven't abstracted the parentheses, and just have a bunch of different types for them. Okay, let's see. skip parentheses, yeah, skip macro expression. This should be tie. Oh, this should be macro expression. This should be tie. And this is the parser. Okay, now let's see. We have the macro expression. Now we'll proceed to make use of it. Okay, read macro type variable. Okay, this is reading the text. Okay, in the macro type, oh yeah, we also need to read the macro expression, but never mind that for now. Let's first take care of the term level. Then we'll figure out how to do everything else. We need this read macro expression. And before we do anything with that, let's take a look at how the read macro variable works. If it is a variable, yeah, it creates this type. Turn type literal variable. Okay, okay, read macro variable. Oh, this is for just for the types. Okay, let's do. Okay, let's go over this is online. And we'll create an utility function. Let macro read macro expression. And we have the macro expression. At least we should. Or maybe this comes very much later in the game. And we need to figure out... Okay, let me pause here. It seems like this is going to be tough. I gotten a handle on it a little. This kind of works, but we need to actually give it the correct union case. Now let's see, how do we do that? Okay, we're actually going to use the term var here, and it's going to have to be renamed later instead of a term variable, type literal variable. Those are all just going to be expressions. The latter passes don't really have any special machinery to differentiate types from anything else inside the macros. So just adding the functionality in the parser should be enough to make it work. And I'm quite confident that I'm not wrong about this. I pretty much designed it like this, with an eye of allowing interpolated macros at some point in the future. So, okay, let's do this. We'll copy paste this. We'll do the usual thing here, fun x, and then we need some kind of range of expression of type expression x and x, and this should be a type variable. And we're still getting an error for some reason. Raw tx per. We have the range. We have, and this is a raw macro. Oh, okay. So what exactly should come? Oh yeah. It's expecting a regular expression instead of a macro. You also need to do something here. and x, because this is a regular expression and this is a macro type, it's kind of expecting a regular expression here, so that's why we're still getting an error. Now let's see, rav macro term variable, and we need the range of expression x and then x. Okay, not bad. And this last case is mostly just going to be copy pasted. We must not forget to make it a type literal variable. Okay, good. Now what's the problem? Why do we still have a type error here? Expecting an environment raw macro by giving a oh whoops, we forgot to apply the environment. We just wrap it all around and put the s at the end. Okay, great. Oh, not bad. That takes care of the term level parser, but we also need this to take care of the type level parser. So let's see. Okay, let's first erase this, then we are going to copy this and we'll use it as a reference. Let's see, where do we have the macro? I mean, it shouldn't be, okay, it should be in root type. Okay, now where is the macro? Here it is. Why didn't it find it a while earlier? I mean, oh yeah. Okay, this is just supposed to be a reference, and we're going to factor out the body, like we have in the macro parser. Okay. Body. Okay, here you have the body, and it's pretty similar to the one that we have here. We just need to also add the macro expression, and now what? I mean, let's remove the comments. And I don't think this macro should be parsing the term level. Oh yeah, we don't allow the variables set on the term level here, I think. Yeah, read macro type variable. If you look at it here, no term variable. So we'll just remove one of the cases here, get rid of the operator, and put the parentheses back. And yeah, this takes care of the parser for the macros. The only thing I'd also like to do is rename these. Let's go here, and we'll rename pretty much everything. Hopefully this doesn't crash the IDE. Sometimes I've had it crashing when doing the renaming. Perfect. Okay, I see that there is some green here. No, not here, but here, and it's telling us that we don't have this expected macro expression. Okay, what's this supposed to be? Okay, expected macro expression, AB. Okay, I see. So yeah, we need to do it like the parentheses. Okay, now let's see, where did I put it? We'll put the errors just below the parentheses. Okay, I'll write them all out. Oh, something like this. These are the first 3 cases, and the other 3 cases are pretty similar. So let's do like this. And we need to close them. Close. Okay, no problem. Do we have any type errors anywhere else? Error list is pretty empty. I guess we can, in fact, try things out. We're done with the initial version, and now it's time to test it out. So what exactly do we do? Okay, we have this. Okay, let's try building it. Oh yes, we do want to save the changes, because what we did is add this escaped variable to the list of semantic token legends. Now, okay, build 1 succeeded. It succeeded. That's good. Now what we have to do is go not into here, but into the VS Code plugin, and then we'll run it. You can just do it using Control F5. It will activate the extension and run it. You know, it's kind of weird. The first time I actually started working on Spiral, the VS Code extension manager wasn't really running. I pressed Control F5 and it wouldn't run. The error eventually went away on its own, but it was pretty annoying. So there's actually some value in you seeing me just press Control F5 to run it. If that doesn't work, then you know that something is wrong with the editor. And yeah, there is a lot of red. Unbound variable SA, expected one of literal variable symbol. There is this thing among the list, but I guess it's not parsing it for some reason. Interesting. Okay, forget all of this. We're going to close this. Now you're going to see how exactly I test the changes to the Spiral language. Forget DML2, forget the backproc1, that shouldn't even be open. And we'll go into the compilation tests. And I'll restart the editor so it gets rid of the errors in the other modules. And this is something like this is actually the very first program that I wrote. You know, does the compiler even run to the end correctly? Like I press F1 here, press the build file, and in fact let me save these changes. I don't want to keep writing commit messages. Now let's try building the file. And does anything happen? Which backend do we even have active? Python plus CUDA. Okay. I don't think we want to be testing on that particular backend. Well, let's try the F# one. We'll revert this change. No, wait, what did I do? And then let's build the file. And what happens right now? Oh, nothing. And that's exactly what should happen. We'll keep going through all these files until we reach an error. And then once we do that, we're going to go back to the parser and the tokenizer and try to figure out where the error is. Okay, this one, if I build it, if I build this, okay, there's some change here, and previously it was what? Now it's true, previously it was empty, and yeah, it should probably return true. Okay, no problem. Okay, I'm going to pause here until we hit a real error, because going through all these tests and is kind of tedious. I don't have automated testing in Spiral. I just go through all the error cases by hand. I mean, through all the testing cases by hand, and actually modify the language that much, and certainly not to really, justify making an automated testing suite. So if I wanted to, it could be implemented for this. But actually the main reason why it's like this is because I am actually looking at the output of the code generator, and I need to test to see it being diffed. And I'm looking at that in the git commits. So, back in 2015, or was it 2016, I can't really remember, I did a compiler project that was on a MOOC online course. And it was the Stanford one. It took me like a month, and that project had unit tests for pretty much everything. And it made it a lot easier to actually build the project. But now that I'm doing things myself, it really matters that I really think about all the changes and observe the results directly. Because a lot of the time, I wasn't really sure whether I even wanted the change. I make some changes, and I look at the outputted code, and I wouldn't really like it. So having to mess with the unit testing and having a rigid textual result that I need to hit wouldn't really be viable. Okay, I'll pause here. Okay, here is the error. It's right in the base of the old core library. I think it's simply passing this $sign as a unary operator. Let's press F1 and we'll inspect the tokens. Let's see. Okay, this is a string and this is a unary operator. Yeah. Okay, let's go back to the code. Let's go back in the tokenizer. And I think the reason why this is happening is because we are trying to parse unary operators before we are trying to parse the macros. And that would lead it to interpreting the $sign as a unary operator. The parser combinators are order sensitive. Okay, so what we need to do is maybe just swap these two. Okay. Let's just try building this and we'll run it again. Publish. Okay, let's try publishing it again. I didn't press. Okay, it's running it. Oh great, it hasn't detected any problems in the workspace. Okay, beautiful. Now based on this I can pretty much tell that the whole core library works. Okay, we don't need these tests anymore. Let's just close them all. Okay, not the Cython experiments. Let's go back to the CUDA experiments. Let's open the project file. Where is it? Here it is. No. What were I even looking at? I can tell that my computer is really humming loudly. Has the compiler maybe gone into an infinite loop? Oh, it hasn't. It just took a while to really parse all of this. Module not loaded. Okay. Okay, this is really weird. Okay, let's go into the base and see what's happening here. And why isn't this being loaded? Okay, we're in core base. Where's the real core? It's here. So what's the problem? Oh well, I did change the tokenizer, but why wouldn't it be loading this? If you look at the terminal, oh yeah, Spiral crashed. Out of memory exception, insufficient memory to continue the execution of the program. And there's a problem in the string builder. And okay, it's in ptext, it's in loop, it's tokenized. It's in tokenized ptext and it's in loop. So maybe it's going into an infinite loop here for some reason in real core. And it's probably in a macro somewhere. And are we using a macro here? Oh, okay. Yeah. This is the first macro. So maybe what's going on is that we're forgetting to advance the tokenizer at some point. So we're going to have to double check that. Let's see, this kind of error, individual tokens. Yeah, we need to go into the macro in ptext, many satisfy, 1L. Okay, this it shouldn't be possible for this to fail. I mean, in such a manner. When you want to satisfy body label, okay, here's what we're going to do. Let's take this macro and we're going to paste it in, put it in one of the compilation tests, something like, okay, like over here. Let's see. We'll copy this, make it test 1A, and we'll go into it. Okay, we'll get rid of all of these. Now what's going on? Okay, it put me in the other thing. And yeah, what we want to do is, oh no, where is the fucking macro? Okay, let me pause here. I'll copy the macro. Okay, here it is. Now let's restart the editor. We'll see what happens. On the Spiral server, I guess it's not this particular macro, maybe it's something else. I mean, this error is in the Tokenizer, so it doesn't matter whether these two variables are in the scope. What about this? And this? Okay, I guess we'll have to go over it one by one, testing out different macros to get to find one which melts down the compiler. Let me pause here. Okay, as far as I could find, in real core, only these two macros were present. So it might turn out to be the case that one of them is the culprit. Let's restart the editor. And as expected, these two are getting parsed as comments. This one is fine, and this one, I think it just crashed the compiler. Yeah, that's in fact what happened. Okay, so why did that happen? Let's try. Okay, let's comment this. Let's comment this. We'll copy it here, and let's you know, try doing something like this. You know, maybe these parentheses are causing trouble. I'm not sure. Now, okay, let's try. Let's restart the editor once more. Now, when I uncomment this, what happens? Spiral crashes. Okay, one last try. Let's get rid of these parentheses. Maybe they are the ones that are causing the issue. Oh, it crashed. Okay, one last thing. Let's do it like this. It also crashes. So for some reason these single quotes are causing trouble. I have no idea why. Maybe it's going into an infinite loop for some weird reason. Okay, now we know what the problem is and we can get closer to resolving it. Let's see. At the outermost level, yeah, we are either parsing the body like this. And here we have the single quote macro, which doesn't work for some reason. So is the problem maybe skip string or something else? Oh yeah, maybe, yeah, we have the closing for the double quotes, but not for the single quotes. And that's a big problem. Okay. Yeah, we need to actually pass the first closing character into this closing and we'll replace that, and the body B, and we need to pass the B into the macro inner. We need the closing character here, and we just, yeah, something like this should be fine. But even if we ignore the closing character, why is it actually, you know, crashing the whole compiler? I mean, it should read up to the end of file and then what? I think it should stop there. Does this maybe go for an infinite length? Okay, this should always be true. Okay, I get it. It should either be the conditional or and not the end of file, end of line actually. Yeah, this is probably what was causing it to crash, because we weren't checking for the end of line, so it went past the end of the array, I think. Still, shouldn't that maybe trigger array out of bounds access? And no, it shouldn't. The reason why it shouldn't is because in peak, when we do go past the length of the string, we just return the UL character. So we had an infinite loop over here. Okay. Okay, let's move on from this. Okay, let's build it again. No. Oh, it's not crashing. Yeah, great. It's not crashing. And can I do something like, you know, put in a string here? Yeah, I could. If we weren't passing the closing character like no, where is the tokenizer? Here, like in oh my god, yeah, like here, then we won't be able to actually write the closing quotes like that in the single quote macro. It would end up being a parsing or a tokenization error. To be more specific. Okay, now we have this done. Okay, compilation tests. I mean, whatever. We'll open this. We'll open this project again. Let's see, package, spiral project. It parses pretty much everything right away. And we have errors apparently. Okay, not these. We have a huge amount of them. And not... okay, why is this unbound? Unbound variable. Yeah, the SA. That should be in SAM. And this backend switch doesn't work anymore. I mean, the double quote grave. I mean, double grave doesn't really work for escaping anymore. And okay, let's restart the editor so we can get rid of those errors in the test. And there are no errors at all here anymore. And yeah, this works well. So now let's try commenting this out. This works, this works, this works. Dim L, list L, and this is an escaped character. I guess yeah, it gets interpreted as a part of the parentheses. If I do a bang, then it becomes white. If I do something like, yeah, as you can see, the regular characters are brown, and this is now whitish. So yeah, okay. The one thing I'm also wondering about is the variable, this thing here. That's no longer valid. Instead, we need this. And if we check that in the inspector, let's see what we'll get. Oh, this is the escaped variable, and this is nothing. These are parentheses, and this is nothing. Yeah, okay, this is an error. This v should be a part of the tag of the escaped variable. So we need to figure out why the range is wrong. The tokens in the inspector are entirely determined by the ranges. Okay, let's see. Escape variable, where are the ranges for that? Escaped var. The range is here. Where are we putting in the range? Oh, it's not a range character, but something else. Let's see. Big definition. Yeah, it should be s from. Okay, s from. Now this is taking into account two characters. Yeah, and this is also wrong. Sorry about that. Okay, is this one wrong as well? Yeah, yes it is. Okay. I mean, okay, now we can try building it again. We'll publish it, we'll close it here so the files don't get locked. Now oh yeah, it compiled. Now let's see. Oh, why doesn't it save the SAM? Okay, let's do it. If we go into here and okay, now what was the issue? The issue was that yeah, we had this slash and v. Oh, great. As you can see, it actually has the correct semantic token. And if we had something like n, it's white. And something like q, which aren't known escape characters, they are yellow. Maybe it's a bit hard to see, so let me zoom it all the way in. You know, it kind of looks pretty similar. Yellow and white look pretty similar. Okay, now let me load up the inspector. It's an escaped character, and this one is the escaped character. And okay, yeah, it's semantic token type escaped variable. Yeah, that's exactly it. And yeah, this should actually work if we try compiling it. We don't need those other ones anymore. We can just erase them. And we've added a new feature to the Spiral language, but we have to also get rid of the v dollars and replace them with /v's. Okay, I made a commit, and now what we need to do is go and change all of these to /. There's a shitload of them in all the different projects, and we'll change them. Okay, let's do it. Now, files to okay, here's how we'll do it. And now we need to change everything. Replace all. Okay, now let's see. What's the problem here? Length A, length B. Oh, what probably happened is simply that it opened this project, and this is an old project, which is based on the older version of the library. So we have this type error. We don't need to worry about it. Now let's see. I guess these are all the changes. I think we can commit them. And what we have to do is now change the most important part, which are the core libraries and the documentation. I mean, they're not the most important part, but they are pretty important. So, okay, the core library, it's right here. Let's do a search for this again. Really? Well, okay, yeah, this isn't really that weird. The older core library didn't have, I think, the $V sign. I mean, this was just for the Python backend. And yeah, only the C backend really needed the with $sign. And back then I was compiling to Cython and wasn't really doing any C style programming in here. So yeah, okay, the call library doesn't need to be changed. And okay, the documentation does, I'm pretty sure of that. The spiral language. Now let's go into the README. Show more options, opening code. And this TOC is automatically generated from the headers inside the markdown file. Now let's see, we'll do a search for v dollar and then we'll replace it with /v. And let's see, we'll go over it one by one. Actually, since this is markdown inside a string, I'm wondering how this will look. So let's open the preview. VS Code has a preview. Okay, it looks okay. I mean, it doesn't really, you know, do something weird like escape the slash. Okay, let's do this. Which one is the next? Click. If I save, yeah, everything is fine, it seems. And yeah, only these examples are using the new operator. I mean the escaped variable operator in macros. Okay. Up. And in fact, we should have left the updating the README for later. Okay, since updating the README is really easy, I'm going to actually undo all of this and leave it for later. We'll only update the README once the new version of Spiral is out. And that's basically it, I think. What we need to do is actually run some programs and see whether they compile properly. And that might be better left for the next video. Let me pause here and I'll think about whether I want to end it. Let's resume from where we left off 2 days ago. 2 days ago I said that I would think about what needs to be doing next. And before releasing a new minor version of Spiral, I think we really should at least test this. And we should try compiling some of the old code to see if it still works. So we're going to have to pick something. I'm not sure what exactly. And since we are at it, let's just take a look at the old ML project. And I forgot exactly. Okay. Let's test out the matrix multiplication to see if it still compiles. Tensor, was it 13 or 14? Okay, matmul. I think this one is the one that we did in I think this one is the latest one that we should be using and not 13 or 12. I'm just wondering whether this one is the synchronous one or the asynchronous one. Oh yeah, it's copying the chunks synchronously. Okay, not bad. Yeah. Okay, yeah, this is the synchronous version and the one that we're going to use in the machine learning library. Unless, of course, I decide to maybe take a look at the Catalyst library and take a look at the Catalyst library again, even though I've trashed it in the series, and try making use of it. Okay, this one has a decent amount of macros, so it's worth compiling. We're going to do a quick test just to see whether that works. Spiral build file. Okay, what's going on? Okay. We still have the F# backend selected. Python and CUDA. And now we'll try compiling this again. Spiral build file. And if you look at the source control, it doesn't seem like there is any difference between the old version and this one. What are these errors? CP float. Oh yes, I understand. This is we're getting this error because we have type checking turned on, but otherwise this would work. It's not a problem. We can just ignore it. Previously, while we were working on the matrix multiply, we didn't have Python type checking turned on. We only figured out the usefulness of that like a video ago, or maybe 2 videos. Okay, and I'm guessing this actually works. So what we have to do is take a look at that backend switch. That's the latest feature in the Spiral. Okay, let's go back to ML2. This is in the SAM module. What we have to do is simply try creating the static array. Let's make a main function something like here. Main equals, and then create okay, not bad. Let's see what happens when we compile this. Okay, this isn't good. It's printing the array. I mean, don't tell me I accidentally am printing the C++ types in the Python backend. That is the most likely case. CUDA array Python list. Okay, let's take a look at the code generator for Python. I probably implemented it for CUDA and then forgot to change which key I'm looking at. Okay, let's see. Not this. CPF device. Let's close the other tabs. Close all but this. Okay, then backend switch. We're looking at the backend name, which should be Python. And then it's printing the wrong type for some reason. I mean, could it be the case that we are maybe importing the wrong backend name? It's telling me that this is the backend name. Okay, let's make this private. Whoops, sorry about that. Okay, I'm not sure why this problem is happening. Whatever, let's try publishing it, and after that we'll try inserting some print statements right in the code generator, so we can see what happens. Oh, one thing it seems like it's doing now, if I try to publish it, it checks whether the file is locked right away instead of compiling it and instead of compiling it in some temporary folder and then trying to copy it. Okay, let's close this, publish. Spiral build file. Yeah, we still get the same error. I will start putting print statements everywhere. Okay, let's, because this really is confusing. Let's print out the backend name here. Okay, print f. When I first started programming in F#, I thought this was very similar to C, but it's actually type checked. So if you do something like 234, you'll get a type error. And over here, I guess we'll print out the type directly. Oh, now let's publish. Let's first close this and then we'll publish it. Actually, I just realized, could it be the case that we have the static array defined somewhere else and it's simply getting overwritten? Because that feels a lot more likely than me. I mean, it shouldn't be. Whatever, let's print it out. Of course, it's still wrong, but if we look at the console, okay, here is the Spiral server, and why is when we build that, why is nothing getting printed? Wait, is anything even happening in this file? Did it load the wrong thing? Okay, if this fails again, I'm going to pause and really think about it. Okay, I'm pausing here so I can figure out what this error is. Sorry about that. I figured it out. I was making a pretty stupid mistake, thinking the problem was in the type. Instead, what was getting printed used to be this thing here. But while working on this macro, I figured out another problem. Now if I do a bang, okay, I guess this still works, but if I do this, and then, yeah, it seems that there's also another infinite loop bug in the Tokenizer. It's really a great thing that we are actually testing this, and we're going to have to figure it out. What's this Tokenizer? C, Tokenizer A, case paren. Oh, so the problem is in the parentheses. I guess there is a parser there that I guess I probably have a many combinator instead of a many one combinator, and that one is going into an infinite loop. I mean, that's kind of just my first guess. Let's check it out. Tokenize. Case paren. Okay, this is many one satisfy as long as it's not a closing parenthesis, but I mean, could it be I'm not really sure. Okay, maybe this first one is valid, but then if body X, oh yeah, we have like two infinite loop bugs. Okay. Okay, what the problem is that this parser diverges when we parse first the opening parentheses, and then it goes all the way past the end of the line, pushing in an infinite amount of characters into the string builder until it runs out of memory. Okay, let's publish this. Okay, it doesn't seem like it's diverging right now. Okay, not bad. Let's try putting this thing inside. That'll be a good test of whether it's doing its job correctly. Okay, now okay, we still need to put in the correct indexing, because this is for the CUDA version. But for the time being, okay, let's do this. We'll build the program, and if you look inside, what the hell? Okay, this is pretty. Wait, did I actually? Oh wait, maybe this requires, maybe this needs to be a function, like this, but why didn't I get a type error? Oh yeah, because we are returning macros, oh for fuck's sake. Even so, shouldn't we have gotten a type error despite that? Backend switch. Like, you know, it should be applying these macros, and that's where the error should have happened. We're going to have to take a look at why we didn't get an error. Okay, this finally prints correctly. And we're going to take a look at why we aren't getting a type error at the partial evaluation time. Oh yeah, this is where it's trying to apply it. I see. So we'd get an error at runtime. Okay, that explains a lot. Okay, now what I'll do is pause and fill out the other backend switch cases. Then we'll be able to use the static arrays on both the Python and the CUDA backends. And that will really help our serialization efforts in the future. Okay, now this should be backend polymorphic. Let's try this out. We have the static array, and then we'll set it to something like set x at index of 0 to 35, and then we'll take a look at what's at that index. That's a pretty simple test. Let's build a file. It's using the CUDA version for some reason. Did I accidentally switch the cases or something? Oh yes, I did. Okay, we can fix this, no problem. Let's build it again. Oh, why is this a type error? Oh, an overload source set item match the provided arguments. Oh, what do you mean? Oh, for fuck's sake. It seems like it's not printing the type. I mean, yeah, that's usually the case in Python. But even so, it will still run this correctly. Let's see, Python debugger. Let's run this 234. So it works. As for this type checker, this is how I'd usually initialize a Python list to, you know, all zeros or something like that. And I'm not really sure how we'd, you know, even if we gave something like a type annotation, like list int, now we'd be getting a type error here. The only thing we could do is maybe initialize it with a 0 like this. But then we'd have to put in a special case into the... I mean, we can still do it. Okay, let's do it. Here's how we can initialize it with the zeros. For example, we'll have to open the... We'll have to make it a bottom-up thing. Over here, we have to put in that we are returning an array, or actually an SA dim L, and we'll do a type case. For example, dim. No, actually, no. We have to test out the type of the element with. Oops. And then if it's an int or actually let's use one of the core library methods for this instead of type case, because with a type case we need to check each individual type, which could get annoying. Let's see, we have the real core here, and type is prim. I think there's also a prim type is type. Okay, this weird. Okay, let me pause here and find the relevant function. Yeah, this is it. We can use this to test whether something is a primitive type, or I thought that maybe we'll have something like integer type is or something like that, but it doesn't seem like it. And so, okay, forget these functions. Instead, I guess we'll just write out all of the cases. Let me show you how. Okay, this isn't going according to plan. I wanted to make something like this, but I just realized that we don't allow union patterns in type case, which is why we are getting this parser error here. Okay, so for getting rid of the annoying type checker error, what we're going to do is something a bit more ingenious. Let's build this. Oh yeah, actually we're going to put, we have to put this here. So this is how it's supposed to go, okay? We'll just do that. But that having said, we're going to have issues when reading from the list in other places. So maybe this isn't really a good solution. But I certainly don't feel like writing out a special case right here for every possible type. I guess in the compiled outputs we'll just ignore the type errors, and I guess that takes care of that. Okay, now let me think. Is there anything in particular we could maybe try compiling, because right now we don't have much here. Okay, let's try maybe the serializer tests. Let's try building this. Okay, so what's the difference? Serializer pi. Oh yeah, this is now the unsigned long. And what are the okay, I'm not sure why we're getting all of these differences here. We're going to try running this to see what's... Oh yeah, this seems fine. it deserializes to the same type on both the GPU and the host. So, okay, let's try the pickler. Okay, so what's the difference here? I'm not sure. Raise call, card king, pot 8, stack 5. Stack 5, pot 8, card king, action history. Okay, this seems perfectly fine. Yeah, it's serializing and deserializing all of this correctly. And if you look at the pickler pi, yeah, only the tag is now an unsigned long value. Okay. This was one of the. This was it being a car tag was a compiler error that we fixed in one of the previous videos. Well, it was causing the negative values to be converted incorrectly when they are being tested. Something like a -2 or a -3 would get converted also to -2 and -3 when they are in a match when they are converted to regular characters or integers. And what we want is the unsigned behavior. We want the high values to be positive integers. I mean, just forget about it if you don't understand what I'm saying. It doesn't matter at all. Okay, so let's see. Do we want to do anything else? And I'm starting to lean towards not really. Yeah, we have this SA list M. Okay, let's take a look at that. Okay, SA. Okay, this is we're going to have to use the regular index. I mean, from the previous for the regular array index. Because right now we have the functionality for both backends in the static array, and we don't want to have to copy paste it here. That would just lead to potential errors. Okay, no problem. Oh yeah, everything here should be fine, I think. Well, okay, what we'll do now is publish a new version of Spiral. If it breaks and somebody is using it, maybe they'll complain in the issues. But in fact, okay, there's one thing that I do want to do. The thing when we have bang bang et and gray in macros. I think I don't really want to reduce the old functionality. So let's actually add that back in. Okay, let's see. Case var. Yeah, in case var, pvar. Yeah, it could be this pvar, and it also could be an escaped character. So how would we represent that? We have the p special character here. Okay, let me think just a little bit about this. I did just a little bit of refactoring here, and now the starting character is being parsed in the case var as well as case paren. So what we're going to do is use the monadic one to first parse the start character. And then we're going to take a look at the next character. For example, if it matches the... Okay, let's do a pick here. In fact, okay, let's do it like this. Skip char start character. And then we'll... okay, what we'll do... escaped character, and that will be okay, this will pass in the range and the starting character, and for this we'll just make it the pvar, this thing here. And then also this. Now this skip character, once it's passed into, yeah, it should be expecting a unit type here. And now it should work properly. And actually, these two already have the starting character applied, and the case paren also has the starting character applied. So yeah, this should work. The only thing that okay, we still have a type error in here somewhere, and that would be wait, did I remove too many parentheses? It seems like I did. Okay, yeah, this is good. Now, this should work, and we'll have the escape character in the parser. But we also need to yeah, the escaped character is for special characters like new line, tab, back, and carriage return. And what we actually need here is the unescaped character. Those are the regular characters that following the slash, like Q, V, E, which don't have any special meaning and just get printed as they are. Like, you can print out any symbol. We just pass them in like this into the parser, and they'll be white. So the user will see that you know, when bang bang is written, or at or grave, that it's a special character. That's just one of the things that I wanted to do. It didn't really sit right with me to break all the functionality after all, for no real reason. You know, who knows? I don't know anyone. I mean, I do know one person who's used Spiral on a project. It was quite an amazing experience to realize that somebody is actually using it. And I don't really know anybody else who's using this language. So who knows? Maybe there are some people in stealth actually using this tool, and not having, you know, bang bang might break their code. Okay, let's try it out. Okay, we have a ton of errors for some reason. Okay, let's see. Let's see where the first one is coming from. Okay, the first one is in real core. Yeah, and the variables don't really work anymore, so we're going to have to figure that out. Let's see. We ended up breaking the entire thing, and we'll have to fix it. Okay, it's trying to skip a character, which is a starting character. Oh crap. Okay. Yeah, it's this is the in case parent is trying to parse the starting character and cannot do it. So okay, here's how we're going to do things. We're actually going to pass the starting character as an argument. Into this. This thing will go back into here. And oops, I didn't mean to do that. Instead of using the tuple operator, we'll be doing it like this. And this will take in the starting character, and this will take in the starting character, and this will also take the starting character as an argument. Yeah, and this is how you can do it. Parsec combinators are very flexible. You can very easily have good errors with them, parse indentation and things like that. This is just the monadic version of the pipe operator. And okay, I'm not going to really go into detail about this, because this is like the end of the video. And if you want to know more about parsing, check out the Fparsec documentation and the tutorial. It's quite good. And all the parsers that I'm using in Spiral have their analog in the Fparsec library. I based it on it. I pretty much learned the parsing by reading the Fparsec docs. Now let's see. Okay, let's try publishing this. Okay, now this thing works. Oh, great. Okay, suppose I did something like, maybe bang bang. Yeah, it's nice. Yeah, great. If I put in a slash, it's CLOG again. Yeah, so it definitely needed to be an unescaped character. Okay, I think this could be, it for this video. We'll send out a new version of Spiral into the two marketplaces. I have this script now, which copies the documentation automatically into the compiler, into the plugin folder, and removes them afterwards, and it publishes them automatically into the to marketplaces. Okay, PowerShell run. In the past videos, I've kept flashing the access token for OS EX. So right now it's in this keys JSON file. PowerShell is actually quite good now that I've gotten a little bit familiar with it. Compared to, in the past year or even 2 years ago, I can just come in and ask Gemini or Bing how to do a particular thing, and they'll get me pretty close to the answer. So it's a bit, so it's a lot more convenient to use technologies that you don't know compared to in the previous times. I guess something good did come out of this, AI bubble. I think the large companies are really overpaying for these AI chatbots, but that is all going to be to our benefit, dear viewers. Okay, the new version is out, and it should be out in about a few minutes. And I'll modify the documentation on the main page, and I guess we'll move on to the next thing. And the next thing would be, now that we have the backend switch, the next thing would be how to serialize the data back and forth, and not just the singular union types, but arrays of them. And we also need to serialize those static arrays between the language boundaries. So we're going to have to extend the serializer that we've been working on, like maybe 3 videos ago, or maybe 2. And we're going to have to extend it, and we're also going to have to make it work on tensors instead of just passing it the array pointers. But that's also pretty easy. We can just make a function that extends the usual one. It's to get at an array from a tensor, you just need to apply the offset to it and then extract the array. It's no problem at all. Okay, let me change the docs, and we'll make the final commit, and then we'll end this video. Okay, leave in the comments whether you prefer this format of doing programming sessions, or whether you want, music and a time lapse. I wanted to try it out like this once. Okay, where's the plugin folder? Okay, this is the plugin folder. We need Nux, Spiral language. And we'll do the thing that we did. Actually, no, we don't need to do a file search. We just need to do this. And then we need to replace it with a slash and v. Let's see, which is the first one? It's in the table of contents. Yeah, no problem. The new oh yeah, I also forgot the change log. And that should be it for this video. I hope that you maybe, if you are interested in parsing, that you found this educational. There also aren't really any videos at all on how to how working on a programming language looks like, and I hope to change. And with videos like this, I hope to change that state of affairs a little. I know that this kind of content won't have a wide audience, but I hope that you haven't found it too boring. So see you in the next video. Peace. Also, don't forget to like and subscribe. Smash that like button.